Hi everyone, welcome to this video. Today we are going to cover complete SQL for beginners in one shot. So starting from basics to advanced level, we are going to cover every SQL concept in detail. And by the end of this video, you'll be very confident in writing SQL queries since we'll be covering practical examples. So without any further ado, let's begin.
So SQL stands for Structured Query Language, which is commonly used for storing, manipulating, and retrieving data stored in relational database. Next, it allows users to create, read, update, and delete data, commonly referred as CRUD operations. तो CRUD operations क्या है? CRUD operations as a full form suggests create, read, update, and delete the data. तो इसको हम एग्जाम्पल से समझते हैं. फॉर एग्जाम्पल यू हैव अ टेबल कॉल्ड स्टूडेंट्स इन अ स्कूल डेटाबेस और इस टेबल में लेट्स सिर्फ 4 कॉलम्स है. आईडी ऑफ द स्टूडेंट, नेम ऑफ द स्टूडेंट, एज ऑफ द स्टूडेंट एंड द ग्रेड ऑफ द स्टूडेंट. फॉर एग्जाम्पल आपको एक नया स्टूडेंट ऐड करना है आपके टेबल के अंदर, तो आप क्रिएट कमांड का यूज़ करेंगे और उस क्रिएट कमांड से आप नया स्टूडेंट का डेटा आप उस डेटाबेस में ऐड कर सकते हैं. तो क्रिएट इज नथिंग बट सी स्टैंड्स फॉर क्रिएट इन CRUD ऑपरेशंस. नाउ फॉर एग्जाम्पल अगर आपको पूरे स्टूडेंट्स की लिस्ट फाइंड आउट करनी है तो आप रीड कमांड का यूज़ करेंगे. उसमें यू विल गेट द लिस्ट ऑफ ऑल द स्टूडेंट्स प्रेजेंट इन योर डेटाबेस. तो रीड स्टैंड्स फॉर आर इन CRUD operations. नाउ द नेक्स्ट इज यू विच इज़ द अपडेट. नाउ फॉर एग्जाम्पल अगर आपको किसी भी स्टूडेंट का ग्रेड चेंज करना है तो उस केस में आपको कुछ अपडेट करना है, आपको अपने डेटाबेस में कुछ चीज़ अपडेट करनी है. तो अपडेट के लिए आप अपडेट कमांड का यूज़ करेंगे. और लास्ट में आता है हमारा डिलीट कमांड. तो डिलीट कमांड में क्या होता है, अगर आपको किसी भी स्टूडेंट का रिकॉर्ड आपको रिमूव करना है, ड्रॉप करना है, तो उस केस में आप डिलीट कमांड का यूज़ करेंगे. तो ये हमारे CRUD ऑपरेशंस के बारे में है. Next, SQL is used across many database systems like MySQL, PostgreSQL, Oracle, SQL Server and SQLite. तो ये हमारे database systems हैं जहाँ पे SQL का यूज़ कर सकते हैं आप. मैं एक और एग्जांपल देती हूँ SQL का. फॉर एग्जांपल अगर आपके पास एक टेबल है कस्टमर्स की जहाँ पे आपके पास कस्टमर्स का डेटा है, तो अगर आपको फैच करना है कि कौन से कस्टमर्स दिल्ली से हैं, तो आप एक नॉर्मल सी SQL क्वेरी लिख के आप फैच कर सकते हैं कि ये वाले जो कस्टमर्स हैं वो दिल्ली से हैं. तो दिस इज़ हाउ SQL इज़ यूज. इफ़ यू वांट टू फिल्टर द डेटा, इफ़ यू वांट टू एनालाइज द डेटा, इफ़ यू वांट टू मैनिपुलेट द डेटा, तो उस केस में आप SQL का यूज़ करते हैं. Next, let's understand why SQL is used. So basically, SQL helps you find and use data stored in relational database. SQL आपको database में stored data को ढूंढने और use करने में help करता है. For example, अगर आपको किसी customer का order history देखना है, SQL query से आप easily find out कर सकते हो. For example, अगर आपको किसी भी student का address देखना है, as we already discussed, तो आप एक SQL query लिख के आप बहुत आसानी से फाइंड कर सकते हो. ओके, नेक्स्ट यू कैन एक्सप्लेन व्हाट काइंड ऑफ डेटा इज स्टोर्ड इन SQL. तो SQL एक्चुअली बताता है कि कौन से टाइप का डेटा आप कर रहे हो. फॉर एग्जांपल नेम्स, नंबर्स या डेट्स. अगर आप नेम स्टोर कर रहे हो तो आपको वेरकेर डेटा टाइप का यूज़ करना पड़ेगा. प्राइस के लिए आपको इंट का यूज़ करना पड़ेगा. डेट के लिए आपको डेट डेटा टाइप का यूज़ करना पड़ेगा. नेक्स्ट, SQL लेट्स यू मेक न्यू टेबल्स एंड चेंज और अपडेट द डेटा इनसाइड देम. तो अगर आप नए टेबल्स बना सकते हो तो आप SQL की हेल्प से नए टेबल्स बना सकते हो या पुराने डेटा को अपडेट और चेंज भी कर सकते हो यूजिंग SQL. फॉर एग्जांपल अगर किसी प्रोडक्ट का प्राइस बदलना है तो आप SQL से अपडेट क्वेरी रन करके उसका प्राइस चेंज कर सकते हो. नेक्स्ट, यू कैन यूज SQL विद अदर लैंग्वेजेस लाइक पाइथन, जावा थ्रू लाइब्रेरीज एंड टूल्स. तो SQL को पाइथन, जावा जैसे प्रोग्रामिंग लैंग्वेज के साथ भी यूज़ किया जाता है वाया लाइब्रेरीज. फॉर एग्जांपल पाइथन में लाइब्रेरीज होती है नमपाई एंड पांडास, जिनको आप यूज़ करके डेटाबेस से डेटा रीड कर सकते हो, राइट कर सकते हो और इवन विजुअलाइज भी कर सकते हो यूजिंग पाइथन लाइब्रेरीज लाइक सीबॉर्न एंड मैटप्लॉट लाइब्रेरी. ओके, नेक्स्ट, यू कैन क्रिएट न्यू डेटाबेसेस इन टेबल्स और रिमूव देम व्हेन नॉट नीडेड. तो SQL से आप नए डेटाबेस और टेबल्स भी बना सकते हो और ज़रूरत ना हो तो उन टेबल्स और डेटाबेसेस को आप डिलीट भी कर सकते हो यूजिंग ड्रॉप कमांड. नेक्स्ट, यू कैन बिल्ड कस्टम व्यूज, फंक्शंस और सेव्ड कमांड्स टू रीयूज एंड ऑर्गेनाइज योर वर्क बेटर. SQL में आप कस्टम व्यूज और फंक्शंस बना सकते हो ताकि रिपीटेटिव काम बार बार ना करना पड़े आपको. फॉर एग्जाम्पल आपने एक व्यू क्रिएट किया जो आपको डेली सेल्स का समरी देता हो, तो यू कैन ईजिली यूज दिस व्यू मल्टीपल टाइम्स जब भी आपको यूज़ करना हो तब. ठीक है. The last point is SQL lets you set permission, so only certain users can access or edit parts of the database. तो अगर आपको SQL में permission set करनी है तो अगर आपको आपके databases में permission set करनी है कि only यही users मेरे database को access कर सकते हैं, तो आप SQL में permission set कर सकते हो, जिससे कुछ ही ऑथराइज्ड यूजर्स जो आप चाहते हो कि यही ऑथराइज्ड यूजर्स ही मेरे डेटा को देख सकते हैं या अपडेट कर सकते हैं, तो आप ये वाला फीचर भी SQL प्रोवाइड करता है. So that's all about why and where the SQL is used. Let's now understand how does SQL work and what are the components present in SQL. तो जब भी आप SQL क्वेरी लिखते हो तो एक्चुअली में वो कैसे काम करती है हम वो देखने वाले हैं यहाँ पे. तो द कंपोनेंट्स दैट आर बिहाइंड SQL क्वेरी आर पार्सर, क्वेरी डिस्पैचर, रिलेशनल इंजन एंड स्टोरेज इंजन. और लेफ्ट हैंड साइड में आप यहाँ पे देख सकते हैं कि ये हमारा डायग्राम है. ये SQL का आर्किटेक्चर डायग्राम है जो बताता है कि एक SQL क्वेरी कैसे रन करती है. तो चलिए देखते हैं हाउ डज अ SQL क्वेरी रन. ओके, तो बेसिकली आप जब भी कोई SQL क्वेरी लिखते हो तो पार्सर उस क्वेरी को एनालाइज करता है, ठीक है, सिंटेक्स चेक करता है जैसे सेमीकॉलम है या नहीं है, या कीवर्ड सही है या नहीं है, या वो ऑथराइजेशन भी चेक करता है कि क्या यूजर्स के पास परमिशन है या नहीं है क्वेरी रन करने के लिए. तो दैट इज द वर्क ऑफ पार्सर. नाउ जो सेकंड है विच इज आर क्वेरी डिस्पैचर, विच इज नथिंग बट द पार्ट ऑफ द क्वेरी लैंग्वेज प्रोसेसर. तो क्वेरी डिस्पैचर क्या करता है कि पार्सर से क्वेरी को लेकर आगे प्रोसेस करता है. ये डिसाइड करता है कि क्वेरी को कैसे और कहाँ भेजना है फॉर फर्दर एक्शन. नाउ द थर्ड वन विच इज द आर रिलेशनल इंजन. तो रिलेशनल इंजन क्या करता है, ये स्मार्ट पार्ट है जो क्वेरी प्लान करता है, कौन से स्टेप्स फॉलो करने हैं ताकि फास्ट और एफिशिएंट रिजल्ट्स मिले. ये पूरा सब कुछ प्लान करता है और इवन बाई कोड बनाता है, एक इंटरमीडिएट कोड बनाता है जो मशीन इजीली समझ सके. नेक्स्ट आता है हमारा स्टोरेज इंजन विच इज़ नथिंग बट DBMS इंजन ओवर हियर. वो एक्चुअल डेटा को रीड या राइट करता है फ्रॉम हार्ड डिस्क और डेटाबेस फाइल्स. ऑल्सो वो बाई कोड फॉलो करके SQL क्वेरी को एग्जीक्यूट करता है और लास्ट में रिजल्ट वापस भेज देता है यूज़र को. तो ये काम होता है स्टोरेज इंजन का. नेक्स्ट अब हम पूरा रिकैप में देखते हैं. सबसे पहले आपने क्वेरी लिखी, नेक्स्ट पार्सर प्लस ऑप्टिमाइजर ने चेक किया और प्लान बनाया, नेक्स्ट क्वेरी डिस्पैचर ने प्लान को DBMS इंजन तक भेजा और स्टोरेज इंजन ने एक्चुअल डेटा एक्सेस करके रिजल्ट वापस भेजा. तो दिस इज द होल वर्किंग प्रोसेस बिहाइंड अ SQL क्वेरी, कि SQL क्वेरी कैसे रन होती है. ये पूरा फुल फेज वर्किंग प्रोसेस है, द कंप्लीट आर्किटेक्चर बिहाइंड SQL. Let's now talk about the commands present in SQL. Now, as you can see here, there are four major commands. The first one is data definition language. The second one is data manipulation language. The third one is data control language, and the fourth one is data query language. So let's understand each of these commands in detail. So the very first one was data definition language. तो DDL कमांड का काम होता है स्ट्रक्चर डिफाइन करना. फॉर एग्जाम्पल टेबल बनाना यूजिंग क्रिएट स्टेटमेंट, उसमें चेंजेस करना यूजिंग ऑल्टर कमांड, या फिर पूरा डेटा डिलीट कर देना. Now, what are the commands involved in DDL? Okay, so there are three major commands as you can see: create command, alter command, and the drop command. So what does create command do is it creates a new table, a view of a table or other object in a database. तो इसका यूज नई tables, views या किसी और database object को बनाने के लिए किया जाता है. The next one is alter command which modifies an existing database object such as a table. तो पहले से जो existing table है या किसी और database object को modify करने के लिए हम alter command का use करते हैं. The third command is drop command which is used to delete an entire table, a view of a table or other object in the database. तो drop command से हम पूरी table या किसी भी object को permanently database से delete कर सकते हैं. तो इन समरी DDL कमांड्स का काम होता है स्ट्रक्चर डिफाइन करना, जैसे टेबल बनाना, उसमें चेंजेस करना या पूरा डिलीट कर देना. नेक्स्ट है हमारा डेटा मैनिपुलेशन लैंग्वेज विच इज आर DML कमांड. तो DML SQL का वो पार्ट है जो डेटा को मैनिपुलेट करने के काम आता है. इसका यूज़ हम एग्जिस्टिंग टेबल्स के अंदर डेटा को ऐड करने के लिए, अपडेट करने के लिए या डिलीट करने के लिए करते हैं. Now there are three commands involved in it. The first one is insert command which is used to create a record. मतलब नए डेटा या रिकॉर्ड को टेबल में ऐड करने के लिए हम insert कमांड का यूज़ करते हैं. जैसे एक नए स्टूडेंट का डिटेल डेटाबेस में डालना है तो हम उसके लिए insert का यूज़ करने वाले. The next one is update command, which is used to modify the records. For example, अगर आपको existing data को बदलना है, जैसे किसी employee का address update करना है, तो आप update का use करने वाले. And the third one is the delete command. तो delete command is used to delete the records of the table. मतलब data को table से हटा देना है. जैसे पुराने या गलत records को delete करना है, कुछ rows को आपको delete करना है. In that case, you will make use of the delete command. तो इन समरी DDL जो डेटा डेफिनेशन लैंग्वेज कमांड था वो स्ट्रक्चर बनाता है, एंड डेटा मैनिपुलेशन लैंग्वेज DML जो है वो स्ट्रक्चर के अंदर का डेटा मैनेज करता है. द नेक्स्ट टाइप ऑफ कमांड इज डेटा कंट्रोल लैंग्वेज, विच इज द DCL कमांड. तो DCL SQL का वो पार्ट है जिसका यूजर्स को एक्सेस देने के लिए, उनसे एक्सेस वापस लेने के लिए होता है. जैसे किसी यूजर को किसी टेबल पे या किसी डेटाबेस पे मुझे एक्सेस देना है, तो आई विल मेक यूज ऑफ DCL कमांड. इसके अंदर दो कमांड्स हैं, which is the grant command and the revoke command. So grant command is used to give the access to the user, while revoke command is used to take back the access from the user. ठीक है, I hope this is quite easy and simple. अब लास्ट में आता है हमारा DQL कमांड, विच इज़ डेटा क्वेरी लैंग्वेज. तो डेटा क्वेरी लैंग्वेज में सिर्फ एक ही मेन कमांड होता है, विच इज़ सिलेक्ट, जिसका काम ये होता है कि हम डेटा को टेबल से फैच कैसे कर सकते हैं. तो यूजिंग सेलेक्ट यू कैन फैच द डेटा विदाउट मॉडिफाइंग इट फ्रॉम द टेबल. इससे हम एनालिसिस कर सकते हैं, रिपोर्टिंग कर सकते हैं, या किसी भी डेटा ड्रिवन डिसीजन के लिए इसका यूज कर सकते हैं. सो दैट्स ऑल अबाउट द मेजर कमांड्स प्रेजेंट इन SQL. In summary, DDL defines the database, DML modifies the data in a table, and DCL secures the data, and DQL fetches the data from the database. So that's all about all these 4 commands.
तो चलिए देखते हैं कि ऐसे कौन कौन से बेसिक टर्म्स हैं जो आपको जरूर पता होने चाहिए अगर आप SQL पढ़ रहे हैं. तो इसमें से नंबर 1 पे है, वो है टेबल. So what a table is, since it is very simple and straightforward, everybody knows it, that table is a collection of related data entries and it consists of columns and rows. So here is an example of a table which represents the quarter-wise revenue and expenses of any business, let's say. Okay. The second most important term is field. So what is a field? Let's see. As we know that every table is broken up into smaller entities called fields. Or in this diagram, every single rectangle over here represents field where we can insert our data. Okay. So the third one is row or record. So what a row or record is? A record, also known as row of a data, is each individual entry that exists in a table. Following is a single row of data or record in the expense table. So this is a kind of row. As you know, row and columns are very, very common, but you must know what a row is and what a column is if you are learning SQL. So row is nothing but a horizontal entity in a table. A row or a record, row is also known as record in SQL. So record is a horizontal entity in a table. Let's now move on to the next one, which is column. So what a column is a vertical entity in a table that contains all the information associated with a specific field in a table. So that's how the vertical thing, this is a column in a row. So the column name is revenue. Okay. The next important term is null. So what a null denotes in SQL. So a null value in a table is a value in a field that appears to be blank, which means a field with a null value is a field with no value. So in this case, it is very important to understand that a null value is different than a zero value or a field that contains spaces. For example, in this table, you can see that there are some blank spaces in the revenue column as well as in the expense column. But in the expense column, you can see there is zero as well. So the blank value will be different from the zero value over here. So again, I'm saying it's very important to understand that a null value is different than a zero value or a field that contains spaces. So this is something which is null. This is something which is null. Okay. But this is something which is zero. It has been assigned a zero value. Okay. So in this case, this is not null, while the revenue of the quarter 2 will be null, while the expense for the quarter 4 will be null. Okay. Let's now move on to another term, which is primary key. So what a primary key is? A primary key is a field in a table that uniquely identifies each row or record in a database table. It must uniquely identify each row or record. Okay. So let's take an example over here. So in this case, this is a simple table which represents the employee information. While in this case, employee ID is primary key. So what a primary key is, it is a field in a table which uniquely identifies each row or record in a database. Primary keys must contain unique values. This is something you have to keep in mind, and a primary key column cannot have null values. A table can have only one primary key, which may consist of single or multiple fields. So there are three most important things you must know that. The first one is it cannot contain null values. The primary key cannot contain null values. Second, it must contain unique values. And the third most is a table can only have one primary key. While if multiple fields are used as a primary key, then they are called a composite key and not a primary key. Let's now move on to the next term, which is foreign key. So what a foreign key is, it is very important term you must know if you want to join two tables. So a foreign key is a key used to link two tables together. This is sometimes called a referencing key as well. So a foreign key is a column or a combination of columns whose values match a primary key in a different table. Let's take an example and understand. So here in this example, we have two tables, one that represents department's information and have two columns, department ID and the respective department name. While the other table represents employee information having four columns, employee ID, first name, last name and the department ID. Now in the departments table, if you see, department ID is the primary key. Okay. While in the employees table, if you see, department ID is the foreign key that references department, because this is the common column in both the tables. Department ID exists here as well and here as well. Okay. So on this particular column, we can actually join these two tables. That's why it is called as foreign key. So what the foreign key does is it ensures that the department ID value in the employees table must match an existing department ID in the departments table. Okay, so that's what the foreign key does is. But there are some few rules that you cannot insert an employee with department ID that does not exist in department. And if you delete a department and it has employees referring it, you will get an error unless you use on delete cascade or handle it manually. So that's all about the important SQL terms you must know.
Let's now move on to understand data type present in SQL. So as you can see here, SQL data types are broadly categorized into 6 major groups. तो यहाँ पर 6 तरह की categories होने वाली हमारे पास, जिसमें से नंबर 1 है numeric data type, number 2 character and string data type, number 3 date and time data type, number 4 binary data types, number 5 boolean data type and number 6 other special data types. Okay. तो यहाँ पर हम पढ़ने वाले कि हर एक ग्रुप में कौन कौन से डेटा टाइप्स प्रेजेंट होते हैं. तो यहाँ पे हम हर एक कैटेगरी को डिस्कस करने वाले हैं कि न्यूमेरिक के अंदर कौन कौन से डेटा टाइप आते हैं, नेक्स्ट कैरेक्टर एंड स्ट्रिंग के अंदर कौन कौन से डेटा टाइप्स आते हैं, एंड डेट एंड टाइप के अंदर कौन कौन से आते हैं, बाइनरी के अंदर कौन कौन से आते हैं, एंड सो ऑन. तो लेट्स स्टार्ट विद द न्यूमेरिक डेटा टाइप. So as from the diagram you can see that numeric data type is broadly categorized into two major categories. Number 1 is exact numeric data type and number 2 is approximate numeric data type. तो चलिए देखते हैं कि exact numeric data type के अंदर कौन कौन से data types आते हैं. तो in the case of exact numeric data type, here are the data type that comes under it. जिसमें से as you can see, big int denotes to large integer numbers, int denotes to standard integer values, then small int is for small integers, then tiny int is for very small integers, then decimal denotes exact fixed point numbers. For example, financial values you can use decimal. Then there is numeric data type, which is like very similar to decimal, and it is used for precision data. Money is for storing monetary values, while small money is used to store smaller monetary values. So these are the data types that comes under exact numeric data type. Let's now move on to approximate numeric data type. जिसके अंदर you would see two data types comes under it. Number 1, which is float, that denotes approximate numeric values, and in the third column you can see the specified range of each of these data types. The next is real, which is like very similar to float but with less precision. So this is all about the numeric data type. Let's now move on to the second category, which we had character and string data type. So character and string data type के अंदर you would see four major data types present. तो जो four major है वो है char, varchar max and the text. तो जो var है, it has a maximum length of 8,000 characters, but it has fixed length. While जो varchar है, it again has the maximum length of 8,000 characters, but इसकी जो length है वो variable length है. So whenever we store any string, definitely we are going to make use of varchar data type because it is more flexible, it has variable length. Okay. नेक्स्ट जो हमारा है थर्ड नंबर पे वो है varchar max.
जो varchar max है यहाँ पे you can see that the maximum length of it is 231 characters while it is present in only SQL Server 2005 only. तो since इसमें limitation है, ये सिर्फ यहाँ पर ही present होता है, that's why we avoid this and mostly ज़्यादा purpose के लिए we use varchar data type. And the next is text, which is again a string and character data type. So these are the data types present that comes under this category. Let's now move on to the date and time data types. तो date and time data types के अंदर हमारे तीन major data types आते हैं, which are date, time and date time. तो date क्या है? It stores the data of the date, and this is the format of this data type: year, month, day. Okay. Next comes time, which stores the data of the time, and this is the format of this data type, which is hour, minute and second. Next is the date time, which actually stores both the date and the time. Okay. And here is the format of this data type, like year, month, day, and then hour, minute, second. So date time को दोनों को merge कर देंगे, तो it's going to be date time data type. Let's now move on to our next category of data type, which is binary data type. तो binary data type के अंदर हमारी again three major data types आते हैं, which are binary, var binary and image. तो binary के अंदर है fixed length binary data, var binary के अंदर है हमारा variable length binary data, and image के अंदर आता है that it stores binary data as images. Okay, so this is all about the binary data types present in SQL. Let's now move on to the next category, which is our boolean data type. तो boolean data type के अंदर सिर्फ एक ही data type present होता है, वो है boolean, that stores a logical value in the form of true or false. Okay. The next major category of data type is special data types, and इसके अंदर हमारे जो भी miscellaneous और other data types आ गए, वो बहुत सारे जो major data types हैं वो यहाँ पर आने वाले हैं, and these are the data types present that comes under other or special data types. जिसमें you would see SQL variant that stores values of various SQL Server supported data types except text and timestamp. Timestamp जो है, it stores a database wide unique number that gets updated every time a row gets updated. Okay. Next is unique identifier, XML cursor, table. So these are the special data types in present in SQL. So guys, this is like a very common interview question that interviewer can ask you कि आपको SQL के data types के बारे में पता है, like कौन कौन से data types present होते हैं. तो in that case आपको बताना है कि यहाँ पर जो SQL के data types है वो 5 to 6 major categories में divided है. And the number one is like numeric, number two is like string or character. Number three was date and time, जिसके अंदर like date time ऐसे आते हैं. Next we have binary data type in SQL. Next we have boolean data type in SQL, and we have special data type in SQL. तो special के अंदर ये वाले आते हैं. If you can even describe the major data types present in SQL, that should be fine. Now if you want to get deep dive into SQL, तो आपको ये जरूर पता होना चाहिए कि database क्या होता है और database के major types कौन-कौन से हैं. So let's begin. So as you can see from the diagram over here, database is broadly categorized into two major types. The first one is the relational database and the second one is non-relational database. So it's very important for you to know that कि database क्या होता है. So what is a database? Database is nothing but the collection of data. Now, as you can see here, database is broadly categorized into two parts. First one is the relational database, while the second one is non-relational database. Now, if we talk about the relational database, what it does is it stores the data in the form of tables. It stores the data in the form of tables that contains rows and columns. तो relational database में हमेशा जो data होता है वो आपके table के format में होता है. While in the non-relational database, the data is not present in the form of tables, while it is present in the form of the document, or it could be key value pair, या फिर it could be your graph database that is present in the form of nodes and entities. तो जो SQL हमारा आता है वो relational database के अंदर आता है. Okay. Now let's consider an example over here. A user wants to connect with data. Okay. Now do you think ये possible है कि user can directly connect with data? No, right? A user cannot directly connect with data. Instead, in order to connect the user to the data, user will have to make use of any software. अब उस software को हम बोलते हैं database management system. Now, a user makes use of database management system to connect with the data. Now let's see what is a relational database and what are the examples that comes under relational database. As I already told कि जो relational database है which stores data in the form of tables. So as you can see here, a relational database stores data in predefined tables that consist of rows and columns. Next, relational database use SQL, structured query language, for data management. Now, as you can know that if a user want to connect with the data, it cannot directly connect with the data. Instead the user will have to make use of a software to connect with the data. The example of the software would be MySQL, jahan pe that is nothing but the database management system. So the examples of the relational databases: MySQL, next PostgreSQL, next Oracle. Okay, so these are the examples of the relational database jahan pe you can use structured query language. Let's now move on to understand non-relational database. So non-relational database क्या होता है? As I already told you, it does not store the data in the form of tables, while it stores in the form of document and key value pairs or the graph database. So here, a non-relational database, which is also known as NoSQL, stores data without a fixed schema, allowing flexibility in data formats. अब ये data formats क्या हो सकते हैं? These data formats can be either document format or it could be either graph format. So let's see what are the examples of the non-relational database. The examples of non-relational database include MongoDB, which stores the data in the form of document, either JPG, PNG. The next example of non-relational database is Redis, which actually stores the data in the form of key value pairs. And another one more example of non-relational database is Neo.js, that stores the data in the form of graph that contains nodes and edges. Okay, so that's all about the database. And जो हमारा SQL is structured query language, that is nothing but the programming language that we use to connect with the data and just analyze the data and filter the data and find the meaningful insights from the data. तो वो SQL हमारा relational database के अंदर आता है. Now that you have got the understanding of what a database is and what are the types of databases, it is now important for you to download a database management system to practice the SQL queries. Hi everyone, welcome to part 5 of our SQL series, where we are going to learn how to download MySQL step by step. So guys, first of all, you have to go on your Chrome browser and then you have to type MySQL download. After that, you can see here the official website of MySQL downloads. Just click on this official website. Okay, once you click on the website, you can see there are 4 tabs over here. Just go to the downloads tab. Next, scroll down and then select the MySQL community download. Just click on this. So once you click on the community downloads option, you will be able to see this screen. So here you have to simply click on MySQL installer for Windows. Once you click on this, you can see here the available releases over here. So you have to select the current version, which is 8.0.42. Next, you have to select the operating system. Automatically, it has detected the Windows. Now there are 2 options to download. You have to click on the second one and just click on the download. After you click on the download, you will be able to see that it asks for login and sign up, but you don't need to do that. You just click on no thanks, just start my download. Okay, so once your download is complete, just right click on this and click open, and then minimize. Now you would see that it asks you for the setup type. So let's choose custom, where we can manually select the products that needs to be installed in the system. Now click on next. Now you can click on MySQL server, just click on it, and again just click on it, and then I want this, so okay. Next, I want to go to the applications where I want MySQL Workbench, then MySQL Workbench, and again I will just drag it to the products to be installed section. And if you want shell, you can download the shell. You can also drag it to there. Let's also go to the documentation. So yeah, documentation also I have selected. Okay, now you need to click on the next, then just execute. So once you click on execute, it starts getting installed. So it is just getting installed one by one, so it might take some time. So this is complete. Now the SQL Workbench is getting installed. Okay, so once all the all the 4 products are installed, you just click on next. Then again click on next. Again click on next. Here the configuration type is development computer set by default. Just click on next. Again click on next. Here just again choose default. Click on next. Now here you have to set up your root password. So you can just set it up over here. I'm setting up my password here. Okay. And guys, you have to remember this password. So once this password is set up, click on next. Again click on next. And here again just keep it default. Click on next. Again execute. So this is done. Now you just click on finish, then next, finish. So as you can see here, okay, so as you can see here, your workbench is downloaded. Now you can simply click on your root instance that you just created using the password. Now just click on this, enter the password that you just created. Make sure to remember it. Save password. And yeah, now this is your workbench, and here we are going to practice our queries. Okay. So guys, you might have seen that environment command. You can also paste the path to download and then verify the MySQL. So now we are finally set to practice our SQL queries. So that's all I wanted to discuss in this video. Share your comments if you are facing any challenges in downloading MySQL. I'll also drop the link in the description box that will help you to directly download the MySQL, and you won't have to go to the complete navigation. Now that you have installed MySQL in your system, it's important for you to understand the most important SQL commands. So let's dive in. So the very first SQL command you must know is select command, which is used to extract the data from a database. The second most important command is update command, which is used to update the data in a database. The third most important command is delete command, which is used to delete the data from a database. The next command is insert into, which is used to insert new data into a database. The fifth command is create database command, which is used to create a new database. Sixth command is alter database. If you want to modify a database, the next important command is the create table command, which is used to create a new table. If you want to modify a table, you can directly make use of the alter table command. Next, if you want to delete a table, you can directly use the command which is drop table command. And next important command is the create index command, which is used to create an index or the search key. The last command is the drop command, which is used to delete an index. So these are the important SQL commands you must know. Now let's implement each of these commands in MySQL and understand how these command works. So this is the interface of MySQL Workbench. Let's now implement each of the command that we just discussed. So first of all, we will create a database. So to create a database, we will make use of the create database command. So let's create a database. Create database. And let's say my database name is shopdb. Okay. Now, if I just run this query and I do refresh all, you can see here that my new database has been created, which is shopdb over here in the left hand side here. This is my new database that has been created. Now I want to use this database. Okay, use shopdb, and in this database I want to create a table. And to create a new table, we have a command that is create table command. So I'm just creating a table. Let's say my table name is orders, create table, and then here we are going to write our table name. Again, here we are going to write our database name. So that's how it's going to work. Now in the table, I will have to mention the columns. What columns I want to include in my table. So first of all, I want to write my order ID, and what would be the data type of it? It would be int, and it's going to be my primary key. Okay. Next, I want to include the customer name, and it would be my varchar data type, and let's say max character limit would be 100. Next let me keep one more column, which is the next column would be product name, and here again the data type would be varchar, and let's say I want to mention the quantity, and here the data type would be int, then price, data type would be decimal, and okay. So this is okay. So if I run this query, okay, so now if I just run this, what I will see is my orders table. So as you can see here, my orders table has been created. If I do refresh all here, so see here in the table section, see my orders table has been created in the left side. As you can see here, this is my orders table. Okay, so now I have created the table. Now what I want to do is I want to insert my data into this table. So to insert your data into the table, you will be writing your insert into command, insert into, and where do you want to insert? You want to insert in your orders table. So insert into orders. And here you are going to mention your column names, which is your order ID. Next, customer name, then it is product name, and then it is quantity, next price. Okay, so so these so these are your column names, and now you want to insert the value. So whatever the values that you want to insert over here is, you will be writing it using comma. So order ID, let's say 1, the customer name is, let's say, Bobbin, then the product name, let's say it's going to be your laptop. Okay, and the quantity that you have purchased is, let's say, 3. So that's how it's going to so that and the price that you have paid for it is like, so 12000. Okay, cool. So I've inserted all the how many I've inserted the number of rows that I want to mention over here. So okay, so now if I just run this query, what I'll be getting is, you will see that my columns have been created, which is the order ID, the customer name, the product name, the quantity, and the price. So that's how you can use the insert into command. Let's now so now that you have your table along with the columns, so let's now extract the data from the table. To extract the data from the table, we are going to make use of the select command. So select star. From select star means we are going to extract all the data from the table. So this is my table name, orders table, select star from order. So if I just run this query, what I got here is I have extracted all the rows that I just inserted here. So whatever the data my table had, it has displayed all the data here. If I want to see any specific column, for example, I only want to see order ID, and only want to see the product name, order ID in the product name. So if I mention order ID comma product name, then it will only show me the order ID and the product name. But what if I want to see all the columns that I have in my table? To do that, I'll make use of star. Yeah, select star from order, from table name. Okay, so that's how select command works. And now, so I'm just giving you an idea over here that how each command works. You don't need to worry. You don't need to worry if you're not understanding it at all. Just take a look that how the commands are actually going, and how do we write SQL queries? How do we write commands? So that's how it works. Now the next command that I want to use here is, for example, I want to delete any specific records from my table. So for example, I want to delete the order ID 3, let's say. Okay, so how it works? So I want to delete, sorry. So I want to write here delete from. So from where you want to delete? From your orders table. And what you want to delete here is where order ID is equals to 3. Okay, so what it will do is, so once you write a SQL query, you'll have to close it with the semicolon. So if you close it to the semicolon, then it won't throw an error. So this is your second query that you have written. Now if you want to run this query, and since it has been now you can see that it has deleted, sorry, it has deleted order ID 1, but I want to delete the order ID 3. Okay. Now that's how it works, that it has deleted. So that's how the delete command works, that it can delete the specific record. So it has deleted the order where order ID is equals to 3. That means it has deleted this one. So that means it has deleted here both 1 and 3, since for before I did 1 and then I did 3. So if you see here, only 4 and 5, so only 2 records are here. Since we had 4 records, 1 and 3 have been deleted, only 2 it's showing now. Okay, so that's how it actually deletes. And once you delete, there is no undo. It will not be, you cannot take it back. So that's how it works. Okay, that's how the commands works. I just wanted to get you a simple example, a practice, so that you can a hands-on visual idea of how do we write SQL commands, how do we write SQL queries. However, we are going to see each and everything in detail now in the upcoming videos. If you want to make use of the alter command, if you want to add a new column in your table, in that case you can simply write the alter command, because this is something you are going to add. So alter table, then this is the orders table. Now what is something that you want to add? You want to add, for example, this is a new column that you want to add, which is your varchar. Okay, so this is your new column. So that's how it works. So let's see if it adds that. If I just run this and just do a refresh all, as you can see here, the delivery status has been added. So a new column has been added. So that's how the alter command works. What does alter command does is it has alter table command is actually modified the table structure. If you even want to change the data type of any column, you can do that using the alter command. So that's how the alter command works. Now, for example, I want to rename a column. So, for example, alter table orders, and let's say I want to rename to customer orders. I don't want to keep it as orders. I want to rename this column to customer orders. So after running this, doing a refresh, you can see that my column has been renamed. So you can see that my table has been renamed to customer orders over here. So that's how the alter command works. If you want to drop the complete database, you can simply directly write drop database and then the database name. But that's going to be very horrible. You will not be able to take your database back. There is no undo after doing a drop command. So make sure that you use it very carefully. So definitely we are going to make use of all these commands in the upcoming videos. That's only I wanted to discuss and help you understand how do we write SQL queries, how commands work. If you're not understanding that's not an issue. We are going to cover each and everything in detail. I just wanted to give you a heads up on how the commands function. How do you create a database? How do you insert some values in a database? How do you extract the data from a database? How you alter a column name in a or how do you alter the column name of any table? So that's how it works. Okay. Today we are going to deal with this sample orders dataset where we have 5 columns: order ID, customer name, product purchased by the respective customer, and order date is the date on which the order was purchased, and order amount is nothing but the amount that the customer has paid to purchase the product. So this is the sample data set we want to deal with. Also here we have some duplicate rows, so we are going to understand how to eliminate those duplicate rows, how to sort the rows based on any column, and let's say it could be order amount or it could be order ID or it could be anything. Okay, so let's dive into MySQL Workbench. Now that moving on to MySQL Workbench, what we will be doing is, first of all, we will be creating a table. So this is the sample table that we had that had 6 columns, and these are the specific rows in the column. So first of all, what I'll do is I'll simply create a database. So I'll just give my database name as orders. So I have created a database over here. One second. Okay. Okay, so my database has been created. If I refresh all, you can see here. One second. So yeah, this database has been created, the orders database. Now in this, I want to create a table. So let me just create a table on this. Create table. And what would be my table name would be order details. Order details. Okay. So I want to create my table. The table name is order details, and here I'm going to specify my columns order ID, and what is the data type of my column is int, comma. The next column that I have is my customer name. So customer name. Okay, and then the data type of it is like varchar, and let's give 100. The maximum limit of the characters is 100. Then the next column that we have is our product. Uh, product, and again the data type is varchar, giving, let's say it's 50, comma. The next is order date, and its format is date format, and its data type is date data type, and the last column that we have is order amount. Okay, and order amount, the data type of this would be decimal, and I'll give 10 comma 2. Okay, now I'll simply close this, and in so I have created a table structure over here that has these many columns. But now I what I want to do is I want to insert my data into the column. So to do that, I'll make use of insert into function. Now I want to insert into my order details, and here I'm going to specify all my columns, order ID, comma, customer name, comma, 1 second, customer name, comma, product, then it was order date, and the next is order amount. Okay, so here now I want to insert the values, so I'm writing values over here, and whatever the values I want to insert in my these columns, I'll simply write order ID 1001, and then it's going to be Rajesh Kumar. So this is nothing but the SQL script I'm writing over here. Okay, I will most probably give you all the script in the description box, so from that you can simply copy it. I'm just giving you a heads up like how to create a table in MySQL Workbench. So next, since it's a string, that's why I'm writing it in inverted commas. And the next was my date, which was 2025-05-20. Okay. Next, it was 55. Oh, sorry, 55,000. Okay, yeah. So that's how we are going to write for all the columns over here. I'm simply copying the values over here now. So I have copied all the remaining values of my table over here. Now if I just run this, I have to use orders database. Now if I just simply run this, so if you see, if you do a refresh all in left hand side, you would see that your table order details has been created. Now if you click on the columns over here, you can see your column names displayed over here, which is the order ID, customer name, product, order date, and order amount. Now I'll write a separate query where I want to display my table. Now to display your table, that means if you want to select all the rows and columns of your table, then how would you do that? If you want to select all the rows and columns of your table, you will simply write select star from table name. So your table name is order details. Order details. Okay, so if you run this query, you can see that all the rows along with all the rows along with all the columns, that means the complete table has been shown over here. So that's how you can display all the rows, all the records of your table. So this is the basic, very, very basic SQL query that you can write. Now, for example, if you want to specify, if you want to only display the order ID column as well as the product column and the order amount column. So only you only want these three columns. Let's say order ID. Here I'm writing display only order ID, product, and order amount. In that case, what you would do is you would specify the column names. So here in this case, select order ID, and you have to put a comma in between the columns. So order ID, the next column that you want to display is the product column, product, next comma, comma, order amount. So comma is very important over here. Now you, if whenever you are done writing your columns, you don't need to write a comma again. Simply write from and your table name. So your table name is order details. Okay. So this is your second query where you want to display some specific columns. So if you want to, so as if I run this query, so just select this part and this is your run button. You can just execute it from here. Just click on this and you would see that the order ID column, the product column and the order amount column has been displayed over here. So this is the query. This is so that's how you can display some of the specific rows if you want. Now, for example, you want to display it. For example, you have a condition that I only want to display the details of only those orders where the product is, let's say, laptop only. Okay. Now, in this case, you have a condition that your prod I want to see only those records, only those rows of my table where my product is laptop. So in that case, you have a condition, and to specify that condition, you will be specifically making use of where clause. So for example, what you would do is select star, because you want to select star means you want to display all the columns. Star means you want to display all the columns of your table from order details. And here you have a condition that your product, so here product is equal to inverted commas laptop. So wherever your product is laptop, I want to close this query using a semicolon. Okay. So what you will be doing over here is you have specified a condition where the product needs to be laptop only. So if you run this query over here, you can see that there are three rows that you can see where the product is laptop, and that's what you wanted to see. Okay, so that's how you can filter out some of the rows if you want based on any condition. We are again going to cover the where clause in more detail in the future videos, in the upcoming videos, but that's how you can do it. For example, if you had a condition, let's say I only want to see the order where I only want to see the details of the order where the order amount is like greater than 50,000. So if I do that, order amount, and here I'll just write a simply greater than sign and 50,000. Okay. Again, we are going to study these comparison operators in more detail in the next video, most probably. So here you can see that so when I just executed this query, it has shown me only the details of the orders where the order amount is like greater than 50,000. Now, if I see my original table, in my original table there are 155,000, 55,000, and 60,000. So that these were the three orders with the 55,000 amount two times and 60,000 amount one time. So again, I'm just doing a cross check. So as you can see that's how easy it is to filter the data, to extract the data based on your requirements. You just need to write some simple queries and it will give you the data that whatever you want. Now, since we have already discussed that we have some duplicates in our the sample data. For example, we have the row number one and the row number 4. These are duplicates because they have the same values. For the order ID 1001, it is again the order ID 1001. The customer name is also same, product is also same. Again, the order date is also the same and order amount is also the same. So my this sample data contains the duplicates. Now what will I do to remove the duplicates? So let's see. Remove duplicates from my sample data. Now in order to remove the duplicate from your sample data, what you will be doing here is you will be making use of the distinct function. So what you will be doing is select distinct, because you don't want to display duplicate entries, you only want the unique records, and to remove the duplicate records you will have to make use of the distinct function over here. Now whenever you see this cross sign, you just need to do a semicolon here. Okay, that means this query will has ended over here. Now I'm writing another query. So now from the just write your table name, select distinct. So whatever the columns that you want to retrieve, you can retrieve. But before, you have to, just after the select clause, you have to write the distinct clause over here. distinct function over here. So if I just run this query, you can see that my duplicates have been removed. I can only see 1001, 1002, 1003, 1004, 1005. Only these many rows. So my duplicate rows has been removed. I only have the unique entries now. So that's how it works. Okay. So I hope you are going clear. I hope you are getting clear with how to write some basic SQL queries. If you want to sort your results or sort your rows on based on some specific column, let's say I want to sort my results based on my customer name. I want to write Anil Mehta where name A starts from here. So I want to sort by the customer name. So to do that, you can simply make use of order by clause from order details. I'm just writing. Now I want to sort by customer name. So if you sort by customer name, let's just run the query over here. So as you can see that this has been sorted based on your customer name. Okay. So Anil, where the name starts from A, has been listed at the top. Then Deepak, then Meera, then Rajesh, and then Sneha. So that's how. Now distinct also I can use so that it will remove the duplicate. So as you can see, that's how it works. But what if I want to sort it by the order ID? In that case, you can simply write order ID. Okay. So that's how. Now you can see that your results have been sorted by order ID. If you want to do it by order amount, you can simply write order by order amount. Okay. So that's how the least order amount is there. But what if you want to display the highest order amount at the top? Then in that case, you will write descending DESC, only DESC. It is ordered in descending order. So just write it like that. In that case, you can see that your order amount has been your rows has been sorted based on your order amount column and showing that it is one second showing that these are in the descending order. So that's how you can write some of the basic SQL queries. I hope you're clear with how to write some of the basic SQL queries. I would suggest please follow along these practical implementation. It's very important for you to get your hands on writing SQL queries. That would only make you feel confident with the learning journey of your SQL.
So basically we are going to cover the arithmetical and logical operators, and we are going to understand how to write SQL queries while making use of the arithmetical and logical operators in SQL. So let's begin. And for each case we are going to cover the example so that it is easier for you to understand how we can write the queries. So let's dive in. So let's move on to discuss the arithmetic operators first of all. So arithmetical operators are basically used to perform mathematical calculations, where the calculations could be either addition, subtraction, multiplication, division, or it could be modulus or remainder. Now, these arithmetical operators are mostly useful in scenarios like calculating totals, if you want to calculate margins, wherever you want to calculate discount, something like this, where you want to actually perform the mathematical calculations. So let's take a look at a very quick example to understand how to make use of the arithmetical operators to write SQL query. So our first example is to calculate the total price while making use of the multiplication operator. So the problem statement says that the store wants to calculate the total price for each order based on the quantity and the unit price. Now you have been given the input table, which is the orders table having 4 columns: the order ID, item name, quantity, and the price per unit. The order ID is nothing but the unique identifier for each table. Item name is nothing but the item that the customer has purchased. The quantity, which is the number of units the customer purchased. And the price per unit is nothing but the price of the product per unit. Now, since what you want to calculate is, you want to calculate the total price for each order. So for the order ID 1, the total price will come out to be the 2 into 500, which is nothing but the multiplication of the quantity and the price per unit. So for the order ID 1, the total price would come out to be 1000. For the order ID 2, the total price would come out to be 1 into 1200, which will be 1200. And for the order ID 3, it will come out to be 3 into 2000, which will be 6000. So basically what we are doing over here is we are simply doing a multiplication on the columns quantity and the price per unit, which is giving you the total price for each order. So your output table would look something like this, and which will be having a new column added, which is the total price column, which is actually calculating the total price for each order by multiplying the quantity and the price per unit. So our final query would look something like this, where I'm going to write all the column names that I want to specifically extract in my select clause, and since I'm referring to my orders table, so I'm writing orders in my from clause. So here the order ID is my first column, item name is my second column, then quantity is my third column, price per unit is my fourth column, and the new column that I have introduced is my total price column, which is I have given the alias, and I have calculated it by multiplying the quantity column and the price per unit column. So that's how you can make use of the arithmetic operators. Okay. Now let's move on to take a look at the second example, where we will be calculating the discounted price using subtraction. So here in this case, the problem statement is just apply a flat discount of rupees 200 on all the items, and since we have the orders table over here, which has two columns, the item name and the price per unit. Okay, so item name is nothing but the products that has been purchased, and price per unit is nothing but the price of these products. Now what you have to do is you just have to simply apply a flat discount of rupees 200 on all the items. That you can simply do it by making use of the subtraction operator. Okay, so here your output table would look something like this. Well, you'll have a new column introduced, which is the discounted price, and you can simply calculate the values of the new column by simply subtracting 200 from the price per unit column. So if you subtract 500 minus 200, it will give out to be 300. Then from 1200 minus 200, it will come out to be 1000. And again and the next one, for the item name Snickers, the 2000 minus 200, it will come out to be 1800. And that's how your final query would look something like this, where we are going to write the column names that we want to extract in my select clause. The first column is item name, the second column is price per unit, and the third column that I just calculated by subtracting 200 from the price per unit column and giving the column alias as discounted price from my orders table. Okay, so that's how you can make use of the arithmetic operators to write SQL queries. Let's now move on to understand the logical operators in SQL. So what logical operators are and why they are used is they are used to combine multiple functions in a where clause. So for example, you have multiple functions, you have 3 to 4 conditions, and you want to mention 3 to 4 conditions in the where clause. That's where you actually make use of the logical operators. There are 3 logical operators that we have. The first one is the AND operator, which is used when all the conditions must be true. The second one is the OR operator, which is used when at least one condition must be true. And the third one is not operator, which is actually used to negate a condition. So these are the logical operators that we have in SQL. Let's now see their implementation by making use of the examples. So the example that we have is to filter the orders using logical operators. So let's take a look at the problem statement over here. Is you just need to get all the orders where either quantity is more than 2 or the unit price is above 1000. Now let's suppose that we have the sample data of the orders, and here the sample data contains 4 columns. The first column is order ID, the second column is item name, the third column is quantity, and the fourth column is price per unit. It is the same table that we actually discussed in the previous example. Now what you want to do is you simply want to retrieve the orders where the quantity either the quantity is more than 2 or the unit price is 1000. So you have 2 conditions, and either one of the condition must be true from these 2 conditions. So this is the case of the OR operator, where at least one condition must be true. It is not the AND operator where both the conditions must be true. Instead, it is the case of the OR operator where at least one condition must be true. So in this case, you are going to so in this case your output table would look something like this, where you are going to have the order ID 2 and order ID 3, because in the order ID 2 your second condition actually satisfies, because the price per unit is actually 1200, which is above 1000. while in the order ID 3, the first condition and the second condition both agrees, because the quantity is like more than 2 and again the price is like more than 1000. But the order ID 1 is not included because the price is not above 1000. Also the quantity is not more than 2 while the quantity is 2. Okay, that's why we have avoided writing the order ID 1 in our output. And here is how I can write my SQL query, where I can simply select star represents that you are extracting all the columns from my orders table, and where in the where clause, since I have two conditions and I'm going to mention the or operator between these two conditions, because at least one of the condition must be true. So that's how I'm going to write my SQL query. Let's move on to take a look at another example where we are supposed to combine and NOR operator both. So the problem statement says is, get all the orders where the item is Snickers and either the quantity is greater than 2 or the price is greater than 1500. So in this case, we have the orders table again, which is the same table that we referred before. So here what you need to do is, you just need to extract the orders where item must be a Snicker. Okay, so this is the condition that must be true, and because we have written and means your all the conditions must be true, and and either quantity should be greater than 2 or price should be greater than 1500. So out of these two conditions, any one of the condition could be true, because or is what is written over here, and or represents that at least one condition must be true. Okay, so in this case we have two conditions. The first condition is like the item must be Snicker, and the second condition is that either the item quantity should be greater than 2 or the item price should be greater than 1500. So that's what the second condition says, and based on this problem statement, I'm going to write my query. So my output table would look something like this, where I only have extracted the details of the order ID 3. Why order ID 1 and order ID 2 have been excluded? Because since the item name must be Snicker and it is not, the item name is t-shirt and jeans, which does not satisfy my first condition itself. That is the reason that I have order ID 3 in my output table. And this is my final query, this is my final query, where I'm just going to write select star from orders where item name is equals to Snickers, which is my first condition, and my second condition is that my quantity should be greater than 2 or price per unit should be greater than 1500. So each of these two conditions could be true, okay, in my second condition. So when it comes to filtering condition, where we have a lot of functions like AND operator, OR operator, IN operator, between operator, like operator, and is null operator. That's what we are going to cover today. So let's discuss each of these clauses and each of these functions in detail and see where these are used. So the very first one is the where clause, which one you're already familiar with, which is actually used when it comes to filtering a specific set of records while writing the SQL query. So that's when the where clause is used, when we are supposed to apply the basic filtering condition. The next one is the AND or operator, which is actually used to combine multiple condition. So as these are the logical operators that we just discussed in the last video. The next one is the IN operator in SQL. So the IN operator helps you to specify multiple values in a where clause. So when you have when you want to match multiple values, that means it's like we can also say it's like a shorthand for multiple OR conditions. When you have multiple OR conditions, then in that case you can simply write IN operator. Also we are going to cover the example behind this operator, so thereon you'll get a clear understanding of how to use this operator when it comes to writing SQL queries. Now the next operator that we have is the between operator. So the between operator is used when it comes to selecting values within a given range. So the values could be either numbers, it could be even text, or it could be even dates. So the between operator is like inclusive, where the begin and end values are included by default. So it's like when it comes to selecting values within a given range, that's where we actually make use of the between operator. Now the next operator that we have is the like operator in SQL. So the like operator is used in a where clause to search for a specified pattern in a column. For example, if we have a pattern match, for example, if you want to retrieve customers whose name starts with the letter A, so this is a question of like a pattern match. So that's where we actually make use of the like operator. Now when it comes to applying the like operator, there are two wildcards that are often used. The first one is the percentage sign wildcard and the second one is the underscore sign wildcard. Now the percentage sign wildcard represents 0, 1 or multiple characters. So when it comes to do a pattern matching when for the multiple characters, in that case we'll make use of the percentage wildcard. The second one was underscore sign, which actually represents one or the single character. Okay, the last operator that is left over here is the is null operator that is used when you want to check for the missing values. So some tables might contain null values. That means those are null values are nothing but the cells with the no data in them at all. So in that case, if you want to filter cells like that, you'll make use of the is null operator. Now let's move on to understand the examples and how do we write these operators while writing the SQL query. So let's move on to discuss the examples over here. So the very first example is here, there we will make use of the where clause along with the and or operator. So let's take a look at the problem statement over here. Is that you're working with a customer database and your goal is to filter customers who either live in Delhi and are younger than 30 or customers who live in Mumbai regardless of their age. Now basically what you have been given over here, you're given some customers sample data set that you have been given, and you want to filter the customers. Now since you can see that you want to filter it, when it comes to filtering, you'll make use of the where clause. Now there have been given some conditions based on which you have to perform the filtering. That the first condition is that the customer who either live in Delhi and are younger than 30. So this is one condition that you have, and the second condition that you have is or. And now there is or between condition 1 and condition 2. That means at least one of the condition must be true. Okay, now the second condition that you have is or the customer who live in Mumbai regardless of their age. So here what you see here is your first condition is that whether the customer's city should be Delhi and the customer's age should be less than 30, that means younger than 30. And the second condition that you have is the customer's city should be Mumbai. Okay, so let's take a look at the input table that we have. So here's the customers table having 4 columns: the customer ID, customer name, customer age, and the customer city. Okay, so now here is the output table where we can see that the customer ID 4 has not been included because it does not match our conditions, because the fun condition that is the city should be Delhi and the age should be less than 30. Okay, so in this case the city is not Delhi and the age is also not 30. That means it's not meeting the first condition. And the second condition was if it is not meeting the condition 1, it should meet the condition 2 at least. Okay, so the condition 2 is that city should be Mumbai, and again the city is Bangalore over here. So that's why we cannot see the customer ID 4 in our output. Along with and apart from that, we can see all the remaining customer ID 1, 2, 3 remaining data of the customers has been displayed because that actually meets our criteria. It either qualifies the condition 1 or it either qualifies the condition 2. Okay, so that's how we are going to approach our question. Now let's write the SQL query to solve this problem. So our SQL query would look something like this. So where I'm going to write select star. Star represents that you're extracting all the columns that you have in your input table from customers. So this is because we are referring to the customers table, that's why you're writing that in the from clause. And next you're applying your condition which is where city is equals to Delhi and age is less than 30. This is your condition 1. And or operator, that's what you're going to use, because either each of the conditions should be true, at least one of the condition from these two conditions should be met. Okay, so the second condition was city is equals to Mumbai. So that's how you are going to write your SQL query. I hope you're clear with this example. So let's now move on to the next example that we have. The example 2 says that here we are going to make use of the in operator and the between operator. So the problem statement is here you want to retrieve the customers who are from Delhi or Mumbai and whose age is between 25 and 35 inclusive. Now let's take a look at the input table, which is a customers table again, that the table that we actually referred in the last question. So here we have the same customer data and this is my output. So here's my customers table, and since you want since it is clear that you want to retrieve the customers, that means you want to filter out the customers. Here we are going to make use of the where clause again, who are from either Delhi or Mumbai. So this is your condition 1, and whose age is between 25 and 35, and this is your condition number 2. And there is and written over here. That means both of these conditions should be met, and based on that we are going to filter our customers. Okay. So the condition 1 was the customer should be either from Delhi or Mumbai. So you can see that there are two conditions over here, two or conditions. In this case, you can simply make use of the in operator, where city in Delhi, Mumbai, you can simply write. So it will simply filter out the customers who are either from the Delhi city or from the Mumbai city. So that's how you're going to make use of the in operator over here. And in the second condition, you can simply write your age should be between 25 and 35. Here you will make use of the between operator. So that's how your output would look like. Here you are going to have the customer ID 2 and customer ID 3, because they actually meets both the conditions. The condition 1, which is the city could be either Mumbai or Delhi, and here for the customer ID 2 you can see that city is Mumbai, and the age is also between 25 and 35. That's why the customer ID 2 is in our output. Next, customer ID 3, again it also meets our both the conditions, that the customer city should be from that the customer city should be Delhi or Mumbai. So here the customer city is Delhi, that means it's meeting the criteria. And the second criteria, the age between 25 and 35, again meeting the criteria. We have excluded writing the customer ID 1 in our output because it's not meeting our condition number 2, which is 25 and 35, that age between 25 and 35, because the age written over here is 24, which is not meeting our condition. And here, since we have and sign in both the condition, that means both the conditions should be met. Now when it comes to customer ID 4, we can see that none of the conditions have been met over here, because the age is 41, that means it does not meet our criteria. And again the city is Bangalore, which is none of our condition. Our conditions our condition says that the city should be either Delhi or Mumbai. Okay. So that's how your output has been derived. Now coming to writing the final query. The final query would look something like this, where we are going to write select star from customers, where city in Delhi, Mumbai would be your first condition and operator that you are going to use, and age between 25 and 35, which is going to be your second condition. Okay. So that's all about the example number 2. Let's now move on to the next example. So in this example, the problem statement says that here you want to find all the users whose name starts with the letter A. Now it is very clear that it is the question of pattern matching, where we are going to make use of the like operators. So let's take a look at the input table that we have, which is the users table. And in the table we have 3 columns: user ID, name, and the email of the user. So now it is very clear that you only want to find out or filter out the users whose names start with the letter A. And it's very clear that you will be getting user ID 1, 2 and 4 in your output, because the names start with the letter A is the Aditi, Aman and Alok. Okay. So now that's how your output table would look like. And when it comes to writing the SQL query, you'll make use of the percentage wildcard here, because there could be multiple characters after 8. It could be 3, or it could be 4, it could be 5, it could be 6. We don't know the exact number of characters that it could have. So that's why when it comes to matching multiple characters, that in that case we actually make use of the percentage wildcard. So here my final query would look something like this, where I'll write select star from users, where name like, and since it is a string, that's why I'm writing in my inverted commas, a percentage. A should be my first character, and later on it could be anything. That means multiple characters could come after A. So here that's how I'm going to write my query. The next example that I would have is for the is null operator, where my problem statement says that here you want to identify users who have not provided an email address. That means the email field is empty or null, given your users table, that the same table that we actually referred in the past question. So again here you only want to filter out the users where email is equals to null, and from the input table it's very clear that the output is going to be user ID 2, details of the user ID 2, where the email ID is null. So now here you can simply write is null operator in the email column, and you can simply filter it with the where clause. So your final query would look something like this, where you will write select star from users where email is null. A subquery in SQL is a query nested inside another query. In simple words, we can say that it is a way to use the result of one query as input for another query. So the inner query, which is the subquery, runs first, and its result is used by the outer query. Let's understand this with the help of an excellent example. Let's say you have a products table having 3 columns: product ID, respective product name, and the price of the product. Now you want to find all the products cheaper than the average price. So how do you do it with the subquery? Let's see that. So this is the query that you'll be writing. Now let's understand what's happening over here. So the query which is highlighted in yellow is the inner query that we wrote to return the average price of the product. Okay. Now this query will actually return the average price of the product. Now we are writing the outer query where we are just making use of less than operator to compare the price of each of the product with the average of the price that we'll get from the inner query. Okay. So the outer query will actually filter and return all the products which are cheaper than the average price of the product. So that's how we can write a subquery. This was just an example. If you didn't get understand how we went through writing the subquery, please don't need to worry. We'll cover more examples in future. Let's now see why do we use subqueries. So subqueries are mainly used to filter data based on dynamic values like averages, totals, maximums, minimums, and all those. Next, they are also used to compare across rows or tables without writing multiple queries. And the third one is subqueries are mostly used to simplify complex logic by breaking them down into smaller steps. So that's why we use subqueries. Let's now move on to the top 5 subquery rules that you must know before writing a subquery. So the rule number 1 is subquery must be enclosed within parentheses. For example, your subquery should look something like this. The rule number 2 says that subquery in SQL always runs first, followed by the main query. So whenever you're writing a subquery which is enclosed in the parentheses, that is going to be done first, and its output is actually used by the main query. That means inner query runs first, the subquery runs first, and then the outer query runs secondly. The third rule is that some systems like MySQL restrict order by in subqueries, and therefore you can use group by instead if needed. So subquery in some of the systems, like in some of the databases, MySQL restrict order by in subqueries. The next rule is if a subquery returns more than one row, you must use operators like in, any, or all, and avoid using is equal to operator with subqueries that return multiple rows. The last and the final rule is that you cannot use between within a SQL query, although it can be used with a main query. So these are the top 5 subquery rules that you must know before writing a subquery. Let's now deep dive into the types of subqueries in SQL. So subqueries come in different forms depending on where they are used and how they behave. So the types of subqueries are: number 1 is the scalar subquery, number 2 is the correlated subquery, and number 3 is the nested subquery. Now nested subqueries are further categorized by where the subquery actually appears. So they are categorized into further 3 types. The number 1 is the subquery written in where clause, number 2 subquery written in the select clause, and number 3 subquery written in from clause. Let's understand each of these subquery types using the example over here. So the number 1 is scalar subquery. So a scalar subquery is a subquery that returns exactly one value, that is a single row and a single column. So it is typically used in a where clause inside the select list or within a case expression. Okay. Now here you just need to find the employee having the maximum salary of all the employees. So here you are given the employee details having 4 columns: employee ID, employee name, respective department of the employee, and the respective salary of that particular employee. Now your query would look something like this that we have written. So here what we are doing is, here we are simply writing since we need to find the employees having the maximum salary of all the employees. So here while writing the query, we'll write a subquery in the where clause showing that salary should be equal to the maximum of the salary. Okay, so here the subquery calculation is, so the query which is highlighted in yellow over here, so this query actually calculates the maximum of the salary. So what it will give me is, it will give me the maximum salary which is present here across all the employees. Okay, now what I actually want to find, I want to find the details of that employee which is having the highest salary. Okay, so here I'm simply comparing my salary should be equal to maximum of the salary, and this inner query will give me the maximum salary. That's why we can actually make use of subqueries to when dealing with such types of problem statements. So your output would look something like this, that is, it is showing the details of the employee 205 and with the name Tanvi, having the salary of 80,000. Now the question is, why do we use a scalar subquery? When you want to compare each row to an aggregate benchmark, that's where you make use of scalar subquery. That is because scalar subquery, what it does is, it actually fetches a single value to use across multiple rows. It actually gives you the single value. So here the output of this scalar subquery would be 80,000, that is the maximum of the salary, and that's where we are actually making use of in our outer query to compare my salary with the maximum of the salary, because I simply want to compute the maximum salary of the employee, details of that employee that is actually having the maximum salary. So this is your scalar subquery which is highlighted in yellow. Okay, so now the second type of subquery is your correlated subquery. A correlated subquery is a subquery that actually depends on the outer query of its value. So it is evaluated once per row of the outer query and references a column from the outer query. So here what it does is, the characteristics of a correlated subquery are that it actually follows a row by row evaluation. That is, the subquery is executed once for each row in the outer query. The second thing you must keep in mind is, it is dynamic independent. That means the inner query uses values from the outer query that makes it dependent on the outer query. And the third point that you must know, that it is actually used for complex filtering. That means correlated subqueries are commonly used for row specific filtering, row by row evaluation. So this is something, these are the keywords that must be clicked when we are talking about correlated subquery. That means row by row evaluation or row specific filtering, ranking or calculations based on other related data. So it actually provides you row specific filtering. So this is kind of complex filtering where correlated subqueries are used. Okay, let's understand the correlated subquery with the help of an example again over here. So here you just need to find students whose GPA is higher than the average GPA of their own department. You have been given the details of the students. So this is the students table that you have, having 4 columns: student ID, respective name of the student, department of the student, and the GPA that the student has. Okay, now since you need to find the students whose GPA is higher than the average GPA of their own department, so your final query would look something like this. So here what you're doing is, you will first compute the average GPA of the department, average GPA of each department. Then finally you will compare it, you'll filter it using the where clause, that your GPA should be actually greater than the average GPA of the department, of each department. Okay, so a subquery references S.department from the outer query, and for every student it calculates the average GPA of their department and then it compares it. So basically S is the alias for the outer query, and outer query, that means the student we are checking. Okay, the subquery which is highlighted in yellow, it computes the average GPA for the same department as the current student in the outer query. Okay, so this is like a classic example of a correlated query where the subquery depends on a column, which is the S.department column from the outer query. Now why we have used it is here because it actually follows the row by row comparisons within groups, and it uses when the subquery needs context from the outer row. Okay, so there is one important thing that you must note, that is a correlated subquery executes once for every row in the outer query. It's like it's running a loop. Okay, But the thing is, it can kill performance on large data sets. So that's why the one optimization tip is that you must convert correlated queries into joins or window functions wherever possible, because correlated subqueries actually kill the performance of the large data sets. Let's now move on to our third type of subqueries, which is nested subqueries. So nested subqueries are the queries which are placed inside another query, typically within the where clause, select clause, or from clauses, and they help break down complex problems by allowing you to use the result of one query as input to another. And these subqueries can return single values, either scalar, multiple rows, or even entire tables depending on the context. So actually this makes it dynamic, as it can return different results for each row depending on the values of the outer query. Now they are further categorized by where the subquery actually appears into three types. One, subquery in the where clause, second, subquery in the select clause, and third, subquery in the from clause. So let's understand each of these again with the help of example. So the part 1, subquery in the where clause. So let's take an example where you just need to get all the customers who live in a city where at least one supplier is located. So your subquery would look something like this. So here what we have done is we have made use of the in operator. So here why in operator, we'll understand it. First of all, let's understand the inner query that it gives. It actually gives me, the inner query gets us a list of unique cities where suppliers are located, okay? And since we just need to get details of the customers who live in a city where at least one supplier is located, okay? So the outer query will actually find all the customers who live in those cities. And since cities will be more than one, that's why we made use of in operator, so that it will consider more than one cities, okay? So the thing is, I would say that this is super useful when you want to match data across two different tables. So for example, if you are targeting customers in locations where your supply chain is already strong, so this is the query you would use. Now there is one important thing that you must note, that you can use in operator or even the exist operator when working with lists in subqueries under the where clause. So here what you will so here while running this inner query, what you'll get is you'll get the list of the cities from your suppliers table, okay? So here's the cities could be many cities, like it could be 3, 4, 5, 6 or so many, okay? And you just want to get the details of the customers, okay, or the names of the customers. So here what you're simply retrieving the names of the customers from the table name that you are writing over here, and where you have just simply provided that city should be in this, okay? So that's how you can write a subquery in the where clause. So here you have written the subquery in the where clause. That's why it comes under the city subquery in the where clause. So although I have not made use of input table and the output table over here, it might be difficult for you to understand, but I just want to make you understand that how to write a subquery in the where clause. No need to get into the deep concept of the subquery, how is it written, because it's difficult for you to understand if the input table, the output table is not given. Okay, so yeah, let's now move on to the second one, which is the subquery in the select clause, so that you will so I'm just giving you these examples so that it's easier for you to just differentiate that this is actually the subquery in the select clause, this is subquery in the from clause, and this is subquery in the where clause. So let's take the example of the subquery in the select clause. So here you just need to get the list of all departments along with how many employees they have. So here the subquery would look something like this. So here this is the perfect example of a subquery written in the select clause, okay? So here you can see that in the select clause only, after a comma, after retrieving one column and then applying a comma, we have written a subquery, okay? So this will actually give me the head count, and here for every department in the departments table, we are calculating how many employees belong to that department. So basically what subquery is giving me, the query which is highlighted in yellow over here, is my subquery. So this subquery runs once per row in the outer query. So each row in the final output will have department name and the number of employees, which are nothing but the head count, okay? So here in this case, we will use this kind of subquery when we just need to attach a metric or a calculated field to each row. Okay, so there is one important thing that you must keep in mind is that these are sometimes called correlated queries because they reference columns from the outer query. Now the third type of subquery was subquery in the from clause. So here let's take another example where you just need to get monthly active users from a login table, and this is the subquery that you will be writing. So this is the perfect example of a subquery in the from clause. So here you can see that you have written select month comma active customers. So these are the columns that you have to retrieve, and in the from clause you have created a subquery which will actually behave as a temporary table over here. So this is like a temporary table that you have actually created by writing a subquery. So monthly states is your table alias, and here you're simply writing order by month. So what you have done here is, so this like a more advanced types of subqueries. So inside the from clause you have created a temporary table. So what this will do is, this temporary table or this subquery, it will actually give you, it will actually calculate the active users per month, and then in the outer query what we are doing is we are simply selecting or extracting data our data that is the active customers, which is the new column that you have introduced over here in the subquery. We are simply extracting this new column month comma active users from this particular data. Okay, so this actually calculates the active users per month, and here in the outer query we simply select and order that data. So we treat the subquery like a normal table that we have actually derived it. So this is perfect when you need to build intermediate steps like aggregations and then query them further all in one go. So that's where it is used. And again, one thing to note that is always give your subquery an alias. That is important, otherwise it won't run. Okay, so let's do a quick recap when to use which subquery. So subquery in a where clause is used when you want to filter rows using values from another table. Then subquery in select clause is used when you want to add calculated data per row like counts or averages. Next, subquery in from clause are used when you need to create a temporary table for further querying or filtering. Okay, table. Okay, so yeah, that's all about the types of subqueries that we have. How to write a subquery in where clause, how to write a subquery in select clause, and how to write a subquery in from clause, like that.
So let's first understand what are SQL joins. So a join lets you combine rows from two or more tables based on a related column between them, usually a primary key and a foreign key. So basically joins are used when we just want to combine data from two or more tables. That's where joins are used. Let's understand this with the help of an excellent example. So for example, let's imagine that you just run an online store and you store a customer information in one table and the orders information in the another table. So basically you have two tables over here. The table one is the customers table where you store only the customer information, columns like customer ID, customer name, and the respective city of the customer. And the second table that you have is related to the orders placed in your store, and the columns or the information that you store is like order ID, the respective customer ID, who placed the order, the respective product that the customer has purchased, and the order date on which the customer has made the purchase. Now, if you see both of these tables very carefully, you can see that the customer ID is something which is common in both the tables over here. So customer ID is the primary key in the customers table, and customer ID is the foreign key in term in the orders table. Okay. So if you want to make a join, you'll actually make use of this particular column, which is the foreign key, which is the customer ID. For example, you just want to answer the questions in which you just need to combine data of both of these tables. For example, the questions could be like, what are the order details along with the customer's name? I just want the order details. I just want the complete product names as well as the customer name. Because here in the orders table, you can see that only the customer ID is written and the customer names are not written. So I actually want the particular customer name as well as the product which the customer has purchased. In that case, you'll have to combine the data of both of these tables. So basically, if in case you just want to combine the data from two or more tables, that's where SQL joins will be used. So I hope you're clear with the concept of SQL joins.
Let's now talk about the types of SQL joins. So the first type is the inner join. So as we can see from the diagram, it returns rows that have matching values in both the tables. The second one is the left join. The left join returns all the rows from the left table and the matched rows from the right table. The third type of join is right join. The right join returns all the rows from the right table and only the matched rows from the left table. The fourth type of join is full join. It is also known as full outer join. The full outer join returns all the rows from the left table as well as all the rows from the right table. Now the fifth type of join is self join. In the case of self join, the table is joined with the records of itself. In that being said, the table is matched with the same table. The next type of join is cross join. So in the cross join, all the records from the left table are matched to each and every record of the right table. So that's all about SQL joins. So let's now understand each join in detail. So let's understand the inner join. The inner join returns records that have matching values in both the tables. Let's now look at the syntax of the SQL inner join. So in the syntax, we will be retrieving the columns that we want from table 1. Then we will use the inner join and we will write the name of our table 2, and we will be joining it on a certain condition, which is the common column in both the tables. So the table 1 dot common column is equal to table 2 dot common column. Let's understand more with the help of an example here. So here we have two tables. One is the employee table and the other one is the department table. And the sample output is the output of the inner join between both the tables. So in this table, in the employees table, we have three columns. That is employee ID, employee name, and the department ID. And the department column has the information about department of those employees with the two columns, department ID and department name. So in this table, we can see in the inner join, we can see that it has only returned the records that have matching values in both the tables. So we can clearly see that Alice with the employee ID 1 has department ID 10 and it matches with the HR department in the departments table. Bob, whose department ID is 2, has department ID 20 and it has been matched with the IT department. Similarly, Charlie with the department ID 3 has employee ID 3 has department ID 30, which matches with the finance department. Similarly, David with the employee ID 4 matches with the HR department. Eva with the employee ID 5 has department ID 20 and which matches with the IT department. Now we can see that Frank, the employee ID 6, Frank with the employee ID 6 is not included in the result because his department ID is null and has no matching department in the department table. Similarly, the marketing department is also not included because no employee has department ID 40. So I hope the output of the left join is clear. Let's now get straight into the left join. So for the left join, it returns all the records from the left table and the matched records from the right table. And the result is null from the right table, from the right side if there is no match. So let's take a look at the syntax of the left join as well. So from the syntax, we can clearly see that the syntax is very similar to the inner join. We just have replaced the inner join with the left join here. Let's understand with the help of the same example that we discussed in the case of inner join. So here we have two tables again, the employee table and the department table. In the employee table, we have three columns, employee ID, employee name, and department ID. And the department table again have two columns, department ID and department name. And we have performed self join, and this is how our sample output table looks like.
So in the sample output table, we have three columns. One is the department employee ID and employee name and department name. So in the left join, we saw that we have taken all the records from the left table and only the matched records from the right table. So here our left table is the employees table and the right table is the department table. So let's understand more in detail. So for the employee name Alice, it has the employee ID 1. It has department ID 10 and the department ID 10 matches with the HR department. Similarly, Bob has employee ID 2 and has department ID 20, which matches with the IT department. Charlie, which has employee ID 3 and a department ID 30, which matches with the finance department. Now, David has department ID 10 in the employee ID 4, and it matches with the HR department. Eva, with the employee ID 5, has department ID 20, which matches with the IT department again. Now, if you take a look, Frank has department ID null. Frank has department ID null, so his department name is null, which is shown in our sample output table because there is no matching department for department ID null. Uh, One more thing to know that the marketing department is not included because the left join focuses on all the rows from the employee table regardless of matches in the departments table. So that's all about the sample output, and I hope the left join is also clear to you. Let's now get straight into the right join. So in the right join, it returns all the records from the right table and the matched records from the left table. And the result is null from the left side if there is no match. Let's now take a look at the syntax of the right join. So the syntax is again very similar. We have just replaced the right join here based on our join type. Let's understand the right join again with the help of the same example of employees in departments which shown the sample output of the right join. So in the sample, when we look at the tables, the employee table has 3 columns, the department table has 2 columns, and then we have made the right join, and then we will see how it is done. So when we see the employee name Alice with the employee ID 1 has department ID 10 and it matches with the HR department as we can see here. Now Bob with the employee ID 2 has department ID 20 which matches with the IT department. Now Charlie, which is the employee ID 3, has department ID 30 which matches with the finance department. David with the employee ID 4 has department ID 10 and it matches with the HR department. Eva with the employee ID 5 and department ID 20 again matches with the department IT. Now Frank is not included in our output as we can see here. Why? Because his department ID is null. And when we talk about marketing department, the department ID 40, the department ID 40 is included with null values for employee ID and employee name here because there are no employees in this department, and since we had to retrieve all the records from the right table, we have done that. So in this output we can clearly see that we have retrieved all the records from the right table, that is our department table, and only the matching records from the left table, which is our employees table. So since marketing, this department name marketing was not present in the employee table, but we had to consider in our output, since we have to consider all the records from the right table. So we have placed it here with the employee name and employee ID as null, since it does not have any matching values for the employee ID and employee name. So I hope the right join is also clear to you. Let's now get straight into full join.
So the full join returns all the records from the left table as well as all the records from the right table, irrespective of anything, like records from the left table without a match in right table and those from right table without a match in the left table will be included as well, with nulls in place where the match is missing. Okay, so let's go to the syntax. So this is our syntax, but one thing to note that this full outer join syntax will not work in MySQL Workbench, because MySQL Workbench does not support this keyword, which is full outer join. And to join this, we will be using another method, that is union, and that I'll demonstrate it further. Now let's understand with the help of example. So in the example, we have considered the same example with the employees table and the department table, and full outer join gives us all the records from the left table as well as all the records from the right table. So from employee ID 1, 2, 3, 4, 5, we can clearly see that it has records with the employee ID, employee name, and department name. But since we have taken the employee ID 6 as well, since we had to take everything from the left table as well as everything from the right table. So for the 6, we have Frank null, and also for the marketing, we have taken with the employee ID name, employee ID null, and the employee name is null. So Frank with the employee ID 6 has department ID null, we can see here. So his department name is also null. And for the marketing department, department ID 40 is included with null values for employee ID and employee name, because there are no employees in this department. So that's all about full join. Let's now talk about the next join condition, which is our self join. So self join is a regular join, but the table is joined with itself. So this can be useful for querying hierarchical data or finding relationships within a single table. So self join is useful in a case when we have to consider the same table to find output. For example, consider scenarios when we have to find the employees that report to certain managers, or those kinds of situations. We use self join. So let's take a look at the syntax of the self join here. So when we talk about the syntax, we will be writing our table 1 and giving it some alias. Again, we will be writing the same table because we will be we will be joining the same table to itself and giving some another alias, and then we will just match down a column, and this is how a syntax of self join will look like. Now the next type of join, which is the last type of join, is which is our cross join. So in the cross join, it returns the Cartesian product of the two tables, which means it returns all the possible combinations of rows from the two tables. So this type of join does not require a relationship between the tables, and it can be joined even without holding any kind of relationship. So let's understand the syntax of cross join here. So here we can simply write the table 1 and cross join table 2. So I hope this is clear. Let's now, all the types of joins are clear. So let's now understand and implement the same example in MySQL Workbench and see how joins works and how we write SQL queries based on join types. So guys, let's write SQL queries for each join type in MySQL Workbench. So here I have already imported both the tables, the employee table and the department table. So let's run this and see the employee table. So in the employee table, as we discussed, we have 3 columns: the employee ID, employee name, and department ID, and there are 6 records. Uh, and for the department table, let's run this code and see. For the department table, again, we have 2 columns: department ID and department name, and with the respective values. So let's first perform the inner join. Let's perform inner join. As we discussed on the syntax, so I'll just write select, and my first table is the employees table. So I'll write my table name here, and I'll give my table name as alias employees as E. And since I'm doing inner join, so I'll just write inner join. And my second table is department table, and I'm giving it as alias D. So the one common column is the department ID. So if we run the employee table, we see the department ID is there, and for the department column again we have the department ID. So this is the only common column that we have in both the tables. So we will be joining these two tables on department ID column. So e dot department ID is equal to d dot department ID. And now the columns that I want to retrieve, I'll write here. So I want employee ID, employee name, and department name. So the employee ID I want it from my employee table. So I'm writing it e dot employee ID. Next I want employee name. So it will be employee name. And the third column that we want is our department name. So d dot department name. Sorry, department name. Cool. So I'll run the query and see what it gives me. So it has given me the same output that we actually discussed. So it has given me only the matching records from both the tables. And see here, we have got the employee ID with the employee name and the department name, which were already mentioned in both the tables. And since we know that the Frank with the employee ID had department ID null, and we can see that it is not included because it was not present in the department table. So that's all about inner join query. Let's now write for the left join. So left join. So the syntax is merely the same. We will just replace it with a left join. So I'm just copying it. I don't want to rewrite it again. So just ending the first query with a semicolon so that it does not shows any kind of error. So the left join, and since I want to retrieve the same columns, so I'll just run this query. Okay, and now we can see that we have got all the records from the left table and only the matching records from the right table, the Frank with the null department name. So that's about the left join. Let's now see for the right join. Right join, I'll make use of the same query with the just replace the left join with the right join, and it will give me all the records from the right table and only the matching records from the left table. So that's about the right join. Just performing it here. So since we got that marketing department had the uh, no respective employee ID and employee name, so uh, we have replaced it with the null, and this is how the right join has worked. My last join type is full outer join. So since I had already mentioned that there is no such keyword as full outer join in MySQL Workbench, but if you work in an Oracle database or any other database, you can directly use this keyword and you can just run your output. But if I do that in MySQL Workbench, I'll get an error. So I'll do it with the help of union condition. So what I will do here is I will first output the records from the left join, and then I'll output the records from the right join, and then I'll just do the union. So it will give me all the records from the left table, all the records from the left join, as well as all the records from the right join. And after merging them, I will get all the records, and that will be same as the full outer join output. So what I'm doing here is I will just write for the left join and for the right join, since I don't want to write it again. So since this is for the left join, this is for the left join, the same I'll just copy the same, and in the middle I'll do union. So union will actually uh, merge both outputs. So there is some error here. Okay, I have to do semicolon in my last query. Fine. So this has to be right join, right join. Sorry guys. Okay, so this is the query of my full outer join. So let's now run this query and see the output of the full outer join. And in the full outer join, for the output, let's make it bigger. Yeah, so we can see that we have got all the records from the left table and all the records from the right table. As we discussed, the sample output is actually which actually matches with our real output here. So let's first understand what are window functions in SQL. So window functions perform calculations across a set of rows that are related to the current row called a window without grouping or collapsing the rows. So basically, window functions lets you perform calculations across some set of rows that are related to the current row. You can think it like this, that if, for example, just want to calculate the running totals, or you want to assign ranks, or even look at previous or next rows, that's where you make use of window functions. So the common use cases of window functions are finding running totals, assigning ranks or row numbers, or computing aggregations without collapsing rows or performing group by operations. The best part over here is that you don't need to use group by operation over here to lose any row details. So you can simply calculate running totals, you can compute aggregations like average or sum, all while keeping each row intact. So let's understand this with the help of an example. So here is our input table that has some order details information, having columns like order ID, customer ID, and amount. Now let's say we just want to know how much each customer has spent in total, but we don't want to collapse the rows. So using a window function, we will get this output where each row remains as it is and a new column, total spent, has been formed, which actually tells us how much the customer has spent overall. So customer A, as you can see from the table, customer A has placed two orders, that is of the amount 100 and 200, and his total shows as 300 in both the rows. While customer B has just placed one order with the amount 300, so their total is also 300. So I hope you're clear with a basic idea of what are window functions and how do they work. Let's now take a look at the syntax that you will make use for a window function while writing SQL query. So the basic syntax is going to be something like this, where we'll be writing the window function on some specific column name over partition by column name, and then we apply the order by, and then we just give it a new column. So that's how our window will be forming. So let's just take a look at each of the functions over here. So here, where window function is nothing but any aggregate or the ranking function, column name 1 is nothing but the column that needs to be selected, that we actually write in our select clause to retrieve the columns. So column name 1 is nothing but a column name. Then secondly, we are just writing the window function. It could be sum, it could be count, it could be min, it could be max, it could be either ranking function or whatever. We are going to explore all of these window functions in detail. Just take a look at the syntax for now. Then we have column name 2, which is nothing but the column on which the window function needs to be applied. Then here we can see that there is column name A in the partition by clause. So it is nothing but the column on which basis partition of rows will be done. And then you can see there is column name B on in the order by clause. So that is the column by which rows are ordered within each partition. And new column is nothing but the name of the new column that will be formed. In this case, it was total spent. In the example that we just discussed, the new column was total spent. Okay. And here the from table name is nothing but the name of the table. So that's how your basic syntax of writing a window function over here. So for the example that we just discussed, your SQL query would look something like this, where you will be writing select order ID, customer ID, and the amount. That will be the rows that we will be retrieving as it is. And next we are forming a window, which is nothing but the total spent, but since we just want to compute the total amount spent by each customer. So here, since the operation that we are doing is sum function, because we want to compute the total, so our window function is sum. Since we want to compute the sum of amount, so we are doing it on the amount column. Then over we are just since we want to compute it for each customer, that's why we have written the customer ID in the partition by clause, since we want to compute for each customer the total amount spent. And here I don't need to make use of order by clause, so I have skipped that, and I have renamed this entire window function as a new column, which is my total spent from orders, since my table name was orders. So that's how you can write a SQL query. Let's now take a look at the types of window functions over here. So basically, I have categorized all the window functions into three major types. The first one is the common window functions that include sum window function, average window function, min window function, max, and the count function. So these are nothing but the aggregation functions. So it could be either sum, it could be either average, it could be either computing minimum or computing maximum or computing the simple count. Next, the second type of window function is ranking window function. There comes in row number, rank, and dense rank. So these are used to actually assign the rank. So these are the ranking window functions we say. And the last one are the value functions, which are lead and lag, that are actually used to access data from rows other than the current row within a specified window of rows. Lead and lag are SQL window functions that are used to access data from previous or the next rows within a defined set of rows. Okay, so that's where whenever you want to access data from the previous row or the next row, that's where you just make use of lead and lag window functions. So let's understand each of these window functions in detail, where first of all we had common window functions that includes all the aggregation functions like sum, average, min, max, and count. So here sum is used when you just want to add up values within a window. So that's where we just make use where, for example, you just want to calculate the total. So that's where sum function is used. For example, when you just want to calculate the total sales per customer, or let's say total salary in a department, or let's say running totals of orders. So that's where you will make use of sum window function. Next comes the average window function. So average is used when you just want to return the average value within a window. It could be like when you just need to find the average score of a student, or it could be average monthly salary or average transaction amount by customer. So that's where you just make use of average window function. The next one is the minimum value function. So this is used when you just want to return the minimum value within a window. For example, you just want to find the first purchase amount or the lowest salary in a team. It could be earliest transaction date for each user. So that's where in such cases you make use of minimum value window function. The next one is the maximum value window function, which is used when you just want to return the maximum value within a window. So the use case of this window function could be like when you just want to compute the highest order value, or you want to find the top salary in a department, or it could be the latest date of transaction for each customer. That's where you make use of max window function. The last one is the count window function, which is used when you want to return the number of rows within a specific window. So for example, it could be used when you just need to count how many orders a customer has placed, or how many employees are there in a team, or how many visits are made by a user. So these could be the examples where you will make use of the count window function. So we can say that each of these functions becomes much more powerful with the over clause that we just see in the syntax. They actually let you analyze data in context without losing row level details. So remember that window functions don't group or collapse data. They just let you keep all the rows intact while still doing calculations across them. Let's now take a look at each of these aggregate functions in detail with the help of examples. So first of all, we'll take a look at the sum window function here. So here you can see in the input table, we have three columns, that is the employee, department, and the sales amount, where each row tells us how much sales an employee has made and which department the employee belongs to. Now let's say you just want to know the total sales made by each department, but you still want to keep all the individual rows. So that's where we'll make use of sum window function with the partition by clause. So here in this case, our output would look something like this, which actually gives us a running total per department while keeping the original rows intact. So you can see the table over here that the department A employees, that's Naira, Vihan, Meher, all show 450, which is the sum of 100 plus 150 plus 200. While department B employees, which are Arjun and Sanvi, both show the department total sales is 700, which is nothing but the sum of their sales amount, which is 300 plus 400, which is 700. So when we write SQL query for this, it would look something like this. So here we are making use of sum window function on the sales amount column, we just want to compute the total sales. That's why we are making use of sum window function on the sales amount column. And here we are doing the partition by clause on the department column. That means we just want to group the data by each department, but since we don't want to collapse the rows, we simply want to compute the sum in a new column. So that's why here we have done the partition by on the department column, and then we have given the complete alias for this new column as department total sales. Okay, so yeah, that's how you can compute the department level totals without writing a group by and without losing the row level details. Let's look at the second example where you will computing the average sales for each department. In the first case, we were computing the total sales for each department, and in this case, since we want to make use of the average window function, so in this case we are computing the average sales for each department. Okay, so here again we have the same table of employees, their departments, and their sales amounts shown over here. Now, since we want to compute the average sales per department, and yeah, that we just want to display it alongside each employee. So your output would look something like this, where you can see that the new column, which is department average sales, have been created over here. So it actually helps you to compute the average of sales amount for each particular department, where we have simply written average of sales amount to calculate the average, and we have done it over partition by department, means that the average is grouped by department. But unlike group by, you don't lose the original rows here. Similarly, you can also compute the minimum and maximum of sales for each department, although I'm not going to discuss this in detail over here. But you can simply write minimum of sales amount over partition by department. That will compute the department minimum sales. And similarly, you can compute the maximum sales for each department as well, while writing the maximum of sales amount over the partition by department as department maximum sales. So that will display for each employee, it will display the lowest and the highest sale in the department. Similarly, you can also count how many employees are in each department using count window function, where you will simply write count window function on the employee column over partition by department. That will actually compute the count of employees for each particular department. So that's how you can make use of the common aggregate window functions over here. Let's now move on to the second type of window functions that we discussed, which are ranking window functions. So as we know, ranking window functions assign a ranking or row number to each row within a partition. So here we have three major types. The first one is row number, which assigns unique row for each partition. The second one is the rank window function that assigns same rank even for ties, and it skips the ranks. And the third one is the dense rank, which actually handles ties. That means it gives same rank for ties and does not skip the next rank. Let's understand more about each of them using example. So here the first one is the row number window function. So here we have, so as we know, row number window function gives unique rankings to each row within its partition, even if two rows have the same salary. So let's understand using an example. Here we have a table of employees. So it contains the columns like employee, the respective department, and the respective salaries. So here, let's say you just want to assign a rank within each department based on who earns the most. So the person who is earning the most should ideally get the rank as 1. So here we'll make use of the row number window function, and let's see how it actually works. So here your output would look something like this. So here since we want to compute, we want to assign rank within each department. So here if you see, there are majorly two departments. Department A having 3 employees, Isha, Kabir and Myra, and department B having 2 employees, Rohan and Tara. Where you can see that Isha and Kabir having the same salary, which is 80,000. And in the output, you can see that the rank that have been assigned using row number function is 1 and 2. Ideally, it should be 1 and 1. But here, it is 1 and 2. You might have noticed. So here, it is important to notice that even if two people having the same salary like Isha and Kabir, they get different ranks as 1 and 2. Similarly, in the department P, as you can see, Rohan and Tara both are having the same salary, which is 60,000. Still, they get ranked as 1 and 2, which is purely based on the order they appear after sorting. So even if values tie, row number does not care. It just gives a unique new number to every single row. Okay, so that's how row number works. So row number always gives a unique number even if there are ties. Okay, even in the case of ties happen. So if when we just want to write a SQL query for this, that is how you will be writing. So here you will simply writing the columns that you want to extract, which is the employee, department, and the salary, and the new column that you will be creating. So here since here we will make use of row number window function. So row number over partition by on the department, since we want to assign rank for each department. So here since we want to assign ranking for each department based on each department, so here you are writing the partition by department. And since you want to make sure that the highest salaried employee should get rank 1, so here you have done the order by on the salary column, and that too in the descending order. Okay, so that's how you make use of you write the window function like this, and here you are just giving the alias of this column as row number, which is nothing but the alias of the new column that you just created. Okay, by assigning the row numbers. So yeah, that's how you just need to write the SQL query. Let's now try the same query with the rank window function instead of row number. So here, as we know that ranking, so here in this case again we will be ranking employees based on their salary in each department. Since we want to rank employees based on their salary in each department using rank window function, so it's important to know that what rank window function actually does. So rank window functions gives the same rank to ideal values. It could be either ties, but it actually skips the next ranks when there are duplicates. So let's see how it works. So here, as you can see, you have the same table, which is the respective employee table having employee, department, and the salary. And here is the output table where you can see that you will apply the rank window function. So here what you will be getting is having the same salary, which is Isha and Kabir. So yeah, Isha and Kabir having the same salary are getting rank 1, which is ideally true. But as you can see here, the Myra, which is having the salary 70,000, is getting rank 3. Ideally it should get rank 2, but rank window function actually skips the rank. Since we have given the same rank to 2 employees over there, so it has skipped the second rank and it has moved on to the third rank. So this happens because rank actually skips the next rank when there is a tie. Okay, so the skipped rank accounts for the number of people sharing the previous rank. That is one important thing that you need to know, that the skipped rank accounts for the number of people sharing the previous rank. Okay, so when we'll write the SQL query for this, your SQL query would look something like this. Since we want to compute the ranking of employees based on their salary in each department, so here we are simply retrieving the 3 columns, that is the employee column, department column, and the salary column. And next we are making use of the rank window function over partition by department, since we want to compute for each department. And here you are doing order by on the salary, which is descending order, since we want to make sure that the employee having the highest salary should get the rank 1. Okay, so yeah, your new column, so we have now given the alias as rank in department. So the new column that has been formed over here having the column name as rank in department. Okay, so yeah, you can see that there is big difference between the row number and the rank window function that we just discussed. What rank function does is it gives the same rank to tied values, but it skips the next number. And what row number does is it simply assigns a unique number to each single row. Okay, even if there are ties, it does not care. It will simply assign ranks like 1, 2, 3 like that. Okay, Now let's finally make use of the dense rank window function. So let's see what dense rank does is. Okay, so here again we are simply taking the same example of the employee's information, and here while applying the dense rank you can see the rank. Just take a look at the rank over here. So here you can see that the same rank has been assigned to Isha and Kabir, which is 1 1, and Myra has ideally got rank number 2. So in this case it does not actually skips the rank. So dense rank is like similar to rank, but it also assigns the same so dense rank is like a more dense rank is ideally more better than rank. Okay, so it does not actually skip any numbers even after a tie. It has given the rank number 2, which was ideally true. Okay, so that's how so I hope it's clear between the dense rank and the row number. So dense rank does not skip any numbers even after a tie. Actually assigns the same rank to ties but does not leave the gaps, just like rank does. Okay, so while writing the SQL query for this, the SQL query would look something like this. Again, here we are making use of dense rank window function over partition by department, since we want to compute the rankings based on each department. That's why we are making use of partition by on the department column, and here we are doing order by on the salary, making sure that the salary should be descending, that is the highest salaried employee should get rank 1. So here we are giving the new column alias as dense rank in department. So that's how your SQL query would look from the employees table. Okay, so let's just wrap it with a quick comparison between row number, rank and dense rank. So in summary, row number does not handle ties, does not skips the rank, while rank gives the same rank to the ties and it also skips the rank. But the dense rank gives same rank to the ties and does not even skip the rank. So you can use row number when you need unique positions, and you can use rank or dense rank when ties matter. But if you want to skip the rank, please make use of rank window function. If you don't want to skip the rank, make use of dense rank window function. So that's how these window functions work. Let's now take a look at the last type of window functions, which are value functions, ideally, which are lead and lag. So here, lead, the syntax of lead window function goes like this: lead column comma offset, which actually returns the value from the next row, and lag column comma offset, which actually returns the value from a previous row. Now let's see what is offset over here. So offset is nothing but simply the number of rows forward from the current row from which you want to fetch the value. Okay, so here the default value of, so here the offset is optional. The default value of offset is 1. You can also set a default value to return when there is no row at that offset. Okay, so let's understand each of these two window functions in detail using example. So here you have the example where you want to find the marks of the previous student and the next student. You are given some student's information having roll number, name, respective name and the respective marks of that particular student. Okay, now you just want to compute the marks of the previous student and the next student in the new column. Okay, so here your output should look something like this, where you are having the information that you already have, which is roll number, name, marks, and you have created two new rows, two new columns over here, which is one is the previous marks, which actually gives you the previous student's marks, and the new column which is next marks, which gives you next student marks. So here if it is 80, so here we don't have the previous student, so the marks for the previous marks are null. For the 75, the previous student marks was 80. For 90, the previous student marks was 75, so here 75. Similarly for 85, previous student marks was 90, which was Chetan's marks, and similarly for 95, the previous student marks was 85, which was for Disha's marks. Similarly, it's compute for the next marks. So here for 80 we have 75, which is Bina's marks. Now for 75 we have Chetan's marks, which is 90, and for 90 we have 85. For 85 we have 95, and for 95 we have null, since we don't have any next student over here. So that's how your output would look like. So let's see how we are going to write a SQL query for this. Okay, Since we just want to so since here in this case the default value of offset is 1, since we only want to skip one row, and we only want to compute the marks of the next student and the previous student, so the default value of offset is 1. So here we have actually made use of lag window function to compute the previous student marks, and lead window function to compute the next student marks. So here we are using lag window function on the marks column. Over order by we are making use over here, since we don't want to compute it. So there is no case of partition by here. So we don't want to separate it for each student or for each. There is no scope of using partition by clause over here. So here since we want to compute for each roll number, so here we have done order by operation on the roll number column for 1, 2, 3, 4, 5, making sure that since if you want to compute the previous marks and the next marks of each student, it is very important for us to make sure that the row numbers are assigned in the descending order. Okay, so here you have written order by roll number as the previous marks and order by roll number as the next marks. So first of all, let's understand what are date and time functions in SQL. So basically, SQL helps you handle dates with ease using built-in functions that it has. So these are helpful for things like filtering data by month or calculating age or finding the difference between two dates. Okay. So let's go over some of the commonly used date functions over here. So first of all that we have is the current date or the get date function, which is actually used to return the today's date. The second function is date add function, which is used when you want to add days or months or years to a specific date. The third one is the date diff function, which is used when you want to find the difference between two specific dates. The fourth one is the format function, which is used when you want to format the date output. Okay. And the last one is the extract function, which is used when you want to pull out year, month and day from a specific date. So let's take a look at the current date or get date function. So this function is used when you want to retrieve the current system date and in some cases time from the server when the database is running. Let's understand this with the help of a simple example where you have the employees data. So this is the sample data that you have, having the columns like employee ID, the respective name of the employee, join date, which is nothing but the joining date on which the employee joined the company. The birth date is nothing but the employee birth date and the respective department name and the respective salary of the employee. So this is the basic information about the employee that we have. Now, let's say you just want to get the today's date. If you're working in MySQL and PostgreSQL, you will make use of the current date function. And your query would look something like this, where you are simply extracting whatever the columns that you want. And if you want to extract the today's date, you will simply write current date as today date from your employees table. Next thing, for if you're working in SQL Server, in that case, you will have to make use of get date function, because current date function will not work in SQL Server, and for that particular use you have get date function that will give you the today's date or the current date. So yeah, the next function that we have is the date add function. So this particular function is used when you want to add days, months or years to any specific date. Let's again take the example of the same employees table where you just want to add 1 year to each employee's join date to find their work anniversary. So basically you have your sample input data like this, and you just want to print the joining date along with their work anniversary, which will be nothing but a year after the joining date. So your output would look something like this, where you will be having a new column added, which is 1 year anniversary, that will show nothing but the date just after an year of the joining date. So for Priya, here it is 2022 7/15. So here the work anniversary is nothing but 2023 7/15. Similarly for Arjun, Meena, Raj and Isha. Now, in order to do this, if you're working in MySQL, you'll make use of date add function, where you will be writing date add. In the bracket, you'll be writing joining date, whichever the column you want to add year, that is 1 year. And here in the comma, you will be writing interval 1 year. Okay, since you just want to add 1 year. But what if you want to add 6 months or let's say 15 days? In that case, you will be simply writing interval 15 day. okay? And if in case it is 6 month, it will be like interval 6 month. So that's how it's going to work. So your query would look something like this, where you're simply extracting the columns like name, join, date, and the new column that you're creating using date add function is this, where you're writing date add join date comma interval 1 year, which will show you the dates after 1 year from the joining date as 1 year anniversary from the employees table. So this is the case of MySQL, and what will happen in case of SQL Server. In the case of SQL Server, your syntax would look something like this, where of using date add function, where you will be writing year comma 1 comma join date. So your final query would look something like this. Since you want to add 1 year, so here you are going to write year, and since it is 1 year, so you're writing 1, and to the column that you are adding is join date. So that's how you are going to write in the case of SQL Server. If it could have been 6 months, you could have simply written here month and then month comma 6 comma join date. If it is 15 days or 20 days, anything like that, in that case you would have written day comma 15 comma join date. So it will be adding the next 15 days after the joining date, okay? And yeah, the new column that it will be forming. So that's how you can make use of date add function. Now what about PostgreSQL? For PostgreSQL, it's like it does not have a direct date add function like some other SQL databases like SQL Server and MySQL have. Instead, PostgreSQL performs date and time arithmetic using the plus and the minus operator. That is nothing but the addition and the subtraction operators with interval literals. For example, if you just want to calculate the 1 year anniversary, in the case of PostgreSQL, your SQL query would look something like this, where you will be writing, where you will be extracting the columns like name and join date, and the third column you're simply adding join date plus interval 1 year. Since you want to add 1 year, so here you are writing interval 1 year as 1 year anniversary. So that's how you can add days or months or years to any specific date in PostgreSQL using like this, okay? Using arithmetic operators like addition. The next function that we have is the datediff function. So here this function calculates the difference between two specific dates. Let's again take the example of the sample data that we have. Here let's just say that we just need to find out how many days each employee has worked, okay? So in this case, you will be writing your SQL query something like this, where you're simply writing select, comma name, comma date diff, current date, comma join date as days worked. So it will give you the respective days, because we are calculating it from now. That's why we are making use of the current date, but so that it will give you the today's date. And you can simply subtract today's date from the joining date. So it will give you the number of days the employee has worked. In SQL Server, the syntax would be something like this, where you will be writing date diff, comma day, comma join date, comma get date. Because here your function to get today's date will be get date and not the current date. So here you will be writing your query something like this, where you are just extracting name and the days of work and the days worked using datediff function. So your syntax would be like, you will be writing day, comma join date, comma get. Why we are writing day here? Because it will give us the number of days. If we will be writing month, in that case it will simply extract the number of months. If in case we write year here, it will extract the number of years. So that's the flexibility we have in SQL Server to extract the year, month, days, like that, okay? Now, what about PostgreSQL? So PostgreSQL does not include a datediff function like some other database systems, for example, SQL Server or MySQL. Instead, it provides alternative methods of direct subtraction to find the difference between dates. So, if in case you want to find out the number of days the employee has worked, your query would look something like this, where you're simply subtracting joining date from the current date, and it will give you the number of days the employee has worked. So your query would be as simple as that, okay? Now, the next function that we have is the date format function. So basically, date format function is used in MySQL to format a date or date time value into a custom string format, like changing this date to a readable format like this, that is 7th August 2025. So it's like extracting parts like month, name, year, etc. Okay, so let's again consider the same example of the employees data that we have. So here in this case, you just need to show the birth date in a readable format. Okay, so here your output should look something like this, where you just need to display the employee name, the respective joining date, and the formatted date like this, where the formatted date is like very readable, that you can simply read it like 15th July 2022. So if you are working in MySQL, the syntax of date format function would be something like this, where you'll be simply writing date format in the bracket. You'll be writing the respective column that you want to format, which is the date column or the join date or anything, and then you'll be applying comma, and here you'll simply writing the format in the format that you want. Okay. So in this case, your query would look something like this, where you have simply written date format function. In the bracket, you have specified the column name, which is the join date, and here you have specified the format, and it will actually format it in the readable format, because in the format where you want to display the day and then the month and then the specific year. So that's how your formatted date would look like. So that's how your query would look like. Okay, now there are few important things that you need to know. That the number one, date format is only available in MySQL. Next, in SQL Server, you would use format or convert function in order to do formatting of dates, and in PostgreSQL you would use toChar function. Okay, so date format function is only and only available in MySQL database. The final or the last function that we have is, which is the extract function. So the extract function is used to pull out the specific parts of a date or timestamp. It could be an year, month, day, week, quarter, hour, minute, or second. The syntax of the extract function would look something like this, where you'll be writing extract part from the date column. So what is part over here? So part is the part of the date that you want to extract. It could be either year, it could be either month, it could be either day, it could be hour, minute, second, quarter, anything. And the date column that we have is nothing but the actual date or timestamp field that from where you are extracting. So let's consider this again with the help of an example where we have the same employees table, and here let's say you just want to show how can you extract the birth month of each employee. Let's say you just want to extract the birth month of each employee. Okay, so here your output would look something like this, where you're simply extracting the name column and the birth month. So your query would be something like this, where you will be writing select name, and here for extracting the birth month, you are making use of the extract function, where you just want to extract the month. So you are writing month from birth date column as birth month from the employees. Now there are few important things that you need to keep in mind, that in the case of SQL Server, instead of extract, you would simply use functions like month and year. For example, in this case, your query would look something like this, where you'll be writing select name month of birth date as birth month, which will extract you the respective birth month of that employee. And in MySQL, both extract and shorthand functions like month and year are available. But in SQL Server, extract function is not available, and only the shorthand functions like month and year are available. So that's all about the datetime functions that we discussed. Let's now move on to the next topic for today, which was common table expressions. So let's understand what common table expressions are, or what a CTE, what CTEs are. So a CTE stands for common table expression. It's more or less like a temporary result set that you can reference within your main SQL query. So it's like almost creating a separate temporary table. So there are few things that you need to keep in mind, that a CTE starts with a with keyword, and it's followed by the name you want to give this query table. You can give it anything based on your choice, and then inside that you write a select query. Okay, so that's how you just write a CTE. I'll help you with the syntax. So the basic syntax of writing a CTE would look something like this, where since you're writing a CTE, so it will start with keyword, and here you can write any CTE name, anything that you want to give, based on your choice, and here as, and in the bracket you'll be writing your select query, and that will actually generate a temporary table, and from that CTE name you can just filter out anything. You can write a separate query out of it. Okay, let's now understand why do we use CTE. Basically CTEs have so many benefits. So they are generally used instead of just regular subqueries, but the question is, why do we use CTEs instead of just regular subqueries? So the answer is, it's very good in terms of readability, that your SQL query is much cleaner and easier to understand when it comes to readability. The second one is reusability. So you can reference the same CTE multiple times. You can reuse it multiple times whenever you want. You just need to create a CTE once and you can use it anytime. Okay. The third one is the modularity. So it's like it makes debugging and maintenance easier, and also it increases the performance time of any SQL query. And the fourth one is it's complex logic simplified. So the CTEs are especially helpful when you want to deal with recursive queries or multiple layers of filtering. So these are the benefits of CTEs, and that's why we just avoid writing subqueries if we have the choice of writing a CTE. So let's understand CTEs with the help of an excellent example where you have a simple employee information having the employee ID, name, respective department, and the salary of the employee. And let's say you just want to find the employees in each department who earns more than average salary of their department. And let's say you just want to find employees in each department who actually earn more than the average salary of their department. So in this case, you'll write your SQL query using a CTE. So what you'll do is you'll first create a CTE to calculate the average salary per department, and in the second step you will simply use that CTE in the main query, applying a filtering condition that the salary of that employee should be greater than the salary of the average salary of the respective department, and it will actually give you the final result. So let's just see how we will write a CTE. So your CTE would look something like this, where what you're doing is you're simply writing a CTE with the name as department average, with DEPT underscore average is nothing but the CTE name, and your CTE is started from with keyword, so with department average is. So here we are writing a query and starting from the select clause. So select department average salary as the average salary from employees group by department. So what we have done inside a CTE is that we have simply calculated the average salary per department here by applying the group by clause on the department column, and here applying the aggregation function, which is the average on the salary, that is giving me the average salary for each department over here. And in the second step, what we are doing is we are simply using that CTE in the main query, and we are doing a join of employees on that CTE on the department column, and so that I can compare, I can actually see the average department salary as the respective employee salary for each particular employee, and then I can simply compare that the employee salary should be greater than the department average salary. Okay, so this is going to be your query. Let's understand this again step by step. Okay, so here what we have done is we used a CTE to calculate the average salary per department in the first step, and then selected the employees whose salary is greater than the average in their department. So after writing this particular CTE, this particular CTE, we have calculated the average salary per department. So this is the temporary table that you will be creating by writing a CTE that will give you the department and the respective average salaries. For HR it is 60,000, for IT it is 81,000, and for finance it is 75,000. Now what you're doing is you're simply comparing each employee's salary with the department's average salary. So let's say let's take for each employee that we have, let's first take for Priya. So Priya belongs to HR department, having salary as 60,000. Now as you can see that the average salary of HR department is also 60,000, which is not greater than 60,000. So hence this will not come in my output, since I only want to find employees who earn more than the average salary of their department. Now coming to the next employee, which is Arjun belonging to the IT department, having the salary as 80,000. Now as we know that the average salary of the IT department is 81,000, which is again less than 81,000, again it will not be included in my output. The next employee is Meena, which is from the finance department, having salary as 75,000, again, which is not greater than 75,000, and it is actually equal. So that's why we are again not considering this in my output. And the last employee that we have is Raj, which belongs to IT department, having salary as 82,000. So 82,000 is actually greater than the average salary of the IT department, which is 81,000. So that's why it actually meets our condition that the employee should have the salary greater than the average in their average salary of their department. Okay, so in this case my output will show the details of Raj. So that's how you can write a CT. So I hope you're clear with writing CTEs, writing subqueries, almost everything. So in this tutorial, I would say we have covered almost all the topics that are related to SQL. Now I would suggest you to please go on practice questions. I have created so many playlists out of which I have created a separate HackerRank playlist, a lead code playlist, and some of the company based questions I have covered in a separate playlist. So I'd suggest you to please go on practice those questions. I'll also attach the link of each of these playlists in the description box so that you can practice SQL questions and get your hands on SQL.
I hope you found this video helpful. Please let me know in the comment section. Also, please like the video, share with your friends, and subscribe to my channel. Thank you. See you soon.